influence our probability of detection. And when we look at our overall suite of approaches to find natural gas leaks, it's this sort of context across these different categories of size, ephemeral, mechanical context, and environmental conditions that will define our success or probability of detection. It appears that you don't find every leak every time. And I think we have to start from that perspective, recognizing that we are, one, going to miss leaks, and two, that we can't count our leak surveys as a census. They are a survey. The more you look, however, the more you find. In that the increased frequency will help us find more leaks, especially those that are ephemeral or those that are harder to find due to environmental conditions. And finally, the methodology we choose, that is what widget we're using to look for leaks, who are the people and how are they trained and what are their motivational frameworks and how do we evaluate their success. And finally, what sort of analytical framework do we look at our results in? These factors will together determine our probability of finding leaks. And I think characterizing those probabilities is an important part of how we define success. And finally, I want to talk about reporting. I think that's come up a number of times today. And to me, it's one of the most important and maybe under-discussed parts. Reporting is learning. And learning is available to others to learn from the more we report. So learning can happen when data is available to us and when we share it publicly. I think there's perhaps a shame that we feel when we report to some degree because we're talking about leaks as failures. If we think about leaks as something that we know happens and we can talk about the leaks that we find and share those results, there's an opportunity for others to improve based on our own finding. Finally, I think that we can achieve better equity and justice in our society if we are reporting leak information on a spatial scale. There's a lot of pushback about reporting about space. However, for example, the U.S. Census Bureau operates divisions called census tracts. And I would advocate that if we were reporting on the census tract scale about leak activity, about activity due to pipeline safety, that it would allow us to track things without risking things that companies regard as sensitive in a spatial perspective. So that's what I wanted to offer as a background. Is that helpful, Erin?
Yes, thank you very much.
Thank you for that chance.
Okay, I'm going to try to advance the slides backwards so we can talk about Section 113. Section 113 requires operators to find and fix leaks using advanced leak detection technology. How are they to achieve this, and what is the type of technology that operators are using? Paul, do you think you can answer this one?
Yeah, yes, I think, leak detection technology has come a long way, even in the last 10 years from what was conventionally used, particularly on downstream distribution. For years, everybody used a technology called flame ionization, FID technology. That was the common thread in the industry. It's pretty much what everybody used. And since that time, things have changed. There's a lot now with optical infrared technologies. There's a lot with laser-based tunable diode laser absorption spectroscopy technologies. There's different technologies with ring down cavity spectroscopy, all some of these crazy words, but these are laboratory type technology that's gotten much more sensitive, more selective, to methane itself and not some of the other hydrocarbons, in cities. And so people have evolved from FID. I'd say as a percentage out there, there's maybe probably less than 20% that still use that have moved over. So to me, that's advanced technology. These technologies have advanced in what they previously used, to do these inspections. And a lot of them afford to do it faster, quicker, and cover more ground more rapidly, and that's a lot of the key, is what Joe was talking about, was that, different leak surveys can produce different results. And so the idea is if you can survey pipe more often and more frequency, you will find more leaks because you got changing environmental conditions as well along the way.
Thank you. Does anybody else want to speak on this issue?
I will.
Yeah.
Yeah, I think that was a really good overview. And when it comes to leak detection, I think that the technology really has advanced a long way. And I want to distinguish between detection and quantification. The quantification of leaks is a little more tricky, but it's amazing what we've seen happen in just I've been with Williams in the natural gas industry now for 10 years, and it's amazing to see how much technology has advanced in that time. And I think it's been really exciting, both from the PHMSA perspective and EPA's perspective of really trying to drive rules and regulations that allow that continued advancement of that technology. Because I think we're going to see it continue to advance the next couple of years.
Okay.
I just want to add a little bit. One, I think that with quantification comes and detection, there are elements of probability that come into this, and as a result, elements of statistics that I think are important. And I don't think they have to be scary stats, nor does everyone in this room have to be an expert in statistics to recognize the value of uncertainty. We may not be able to find every leak, nor can we precisely identify the leak magnitude. It might be plus or minus 50%. It might be minus 60% to plus 200% in our uncertainty. But this is part of where we are, and we have to embrace that, and we have to get used to it, and we have to move forward and not wait for something that we think is perfect, and when that might actually be the environmental limit of our potential to characterize leak magnitudes. We're going to have to move forward within that.
Thank you. Erin, did you want to say something?
Yeah, maybe just to add a little bit onto this great discussion of, what is advanced leak detection technology and what are sort of the options. I think it's really important to recognize that there isn't a one size fits all approach, and there's a huge range of options out there, and what sort of works best is continuing to improve almost continuously as more technologies become commercially available. And what we see a lot when interacting with operators and when doing field research is that there's, often using a combination of methane detection technologies is the best solution. And so not just trying to pick a single technology and say, this is what we're going to apply across the board, but rather really thinking about how do we combine, different leak survey frequencies with different technologies to make sure that we're covering the most ground possible, but also getting, the best quantification possible, to what Mark mentioned earlier, is really valuable. And, we're talking about leak detection under Section 113, which is really focused on finding and fixing leaks. But this does bring to mind for me sort of a related concept of methane quantification, where we often talk about, the combination of bottom up and top down measurements is the best way to get a sense of what's happening on your system. And I think certainly looking forward to see how advanced leak detection is defined by PHMSA in the forthcoming rule. But certainly, want to emphasize sort of the value of applying multiple technologies as well as work practices.
Thank you. So you spoke a bit about this in your question, but I am curious about, does the type of leak detection technology vary substantially depending on what state of transport the gas is in? Does leak detection during transmission look a lot different from distribution leak detection? And do transmission operators have different costs compared to distribution? I'm really curious about this.
Yeah, I can answer that. If you look at downstream distribution, and I'm talking, the neighborhoods you generally live in, are wall-to-wall concrete in many cases, concrete in downtown cities like here in New Orleans or New York City. And so those are a little different too. And you've got canopies, tree canopies, you've got overhangs of homes and houses over meters and things of that sort. So there's not as much aerial type inspections in those type. Most of them are on foot patrol and or vehicle, where vehicles will drive the city streets of different types of technology. And some of the advance now is the ability of not doing it in parts per million anymore, like conventionally, but in parts per billion, to give you a much more sensitivity and a bigger range. Now, if I take that technology out on a transmission line, you have, cut right-of-ways, canopies generally trimmed and things of that sort. And so you can do inspections with helicopters with leak detection technology. You can use drones, you can use fixed wing helicopters, or even work in satellite technology now, because you have line of sight that you don't have in a city type system that makes it more difficult. And now some of that's being applied to the E&P side, the upstream on the environmental and production. We've all heard these orphan and abandoned wells now, and trying to locate and find these. A lot of these are being done by aerial technologies as well. So there are different technologies for different applications for different, whether you're upstream, midstream, or downstream.
Great.
Well, I was going to add one more thing, and that is that there are emerging technologies. There are, I would argue, proven technologies that exist at each of the scales where we're working. There are improvements in those existing technologies that are genuine improvement. And I am always thankful when I go to the grocery store and I can look at the nutrition information on a box of cereal or whatever I buy. But I think we're entering a stage that I hope is short-lived, where nutrition information on some of the advanced leak detection providers is a little bit short to lacking. And I'm hopeful that we can identify mechanisms through which we can evaluate things like detection limits and detection probabilities, so that we're not overselling things like the potential for satellite information to help us find the small leaks in distribution systems that we might hope for. A satellite is a wonderful concept, but our ability to see things from space is functionally limited by physics. Scientists might have a pretty good idea of what those limits are, and I think we're asking a lot of utility operators to become scientists in order to evaluate some of the offerings that are out there. I hope that makes sense.
Yeah. Anything else?
Yeah, I think it's a really interesting question, because it is my favorite answer as an environmental professional is it depends. There are so many factors that come into play. I think the GTI, the Collaboratory for Advancing Methane Science, the CAMS team, published a white paper on satellite technology. And if you think you kind of remotely understand some things, read one of those white papers. It's unbelievable how much goes into the ability of some of these technologies to truly detect and quantify. But yeah, as you think through the natural gas value chain, it's a really interesting discussion. What we just mentioned on local distribution. Usually it's a single company operating those assets in a fixed geographic space. But then in that situation, you do have the concrete jungle, the overhangs of houses. And then as you go farther upstream, it becomes also geographically limited, but then multiple operators in the same space. So it begins to lend towards array concepts, or even coalitions across industry or partnerships with government to cost effectively to provide the monitoring services. So I think as this continues to develop out as we move forward, and it's interesting because it's not a single regulatory agency. A lot of agencies have involvement in this advanced leak detection space. So it definitely is going to be a really interesting collaborative space to be in the next couple of years.
Thank you. I'm really interested to hear from PHMSA what you can say about what they're thinking on ALD, what are allowable methods, what isn't ALD. Are there going to be performance standards or other requirements? What can you tell us? Can you give us any preview on your thinking?
Well, if you weren't in the CO2 rulemaking, since it is asking about a rule, we are limited to ex parte. We can't tell you what's in the rule. I think it's fair to say publicly we've taken some measures in our special permits, which these are all publicly, but we've had some conditions on things like using leak detection equipment versus relying so much on. If anyone doesn't know, a lot of odorant is used on distribution, and I agree with all the statements that have made on transmission versus distribution. Putting my technical hat on, usually it's some percentage of flow over time that you're looking for. So as the pressure drops more and more, usually the distribution and some transmission operators do put odorant in it, particularly if you're getting to more populated areas. But then questions come up, after an incident, member of the public says, "Oh yeah, I called in the odor. Company says they didn't get it. What's the question?" Things like that. This is also in public domain, but our colleagues from NTSB give us some recommendations on some of these incidents on things like in-home methane detectors. Should we start using that equipment versus, again, relying so much on odorant? There is an issue sometimes relying too much on technology. I mentioned, one of our 2012 studies that, everyone wants to do everything through computational pipeline monitoring, which you can do it liquid and certain gas, but we had a number of what we found in that study, that even if you have this supposedly most 24/7 robust technology, it's still landowners that are finding those leaks first. So those aspects. I will say an angle we're looking at is trying to shift the paradigm. And again, this is in special permits as well, but changing that dynamic from managing leaks to actually fixing leaks. So if anyone doesn't know, there's a grading system out there, and GPTC has guidance out there. Grade 1 is typically your imminent hazard. Usually no one plays games with those. But then others are like scheduled leaks, gives you some time. And then others are like the grade 3s, which are lowest level, that just keeps them going for a while. And essentially that's a managing leak program. What we're trying to encourage, the thought is, let's shift that to actually fixing those leaks. and figuring out, so you don't just keep them on the books, but get to the point of actually fixing them as well. So again, publicly, and if anyone wants, we can send you some examples of at least what we're having in special permits, but things like, again, surveying, improving that, the whole process. Aaron brought up a little bit about the methane reduction, which is a little more 114, but also do they have a process on at least looking what's out there? And kind of in the methane reduction side, we are seeing, at least in our 114 inspection so far, we do see a number of operators are using the voluntary programs that are already out there through EPA and others. May or not be a complete slam dunk for meeting 114 and possibly these, but again, I know some tools in a toolbox that operators are using. The other one thing I will mention about rulemaking, which I don't know if it was touched on the last session, at the end of the day, some costs do come into this, and sometimes we are limited in having a cost-benefit analysis on some of these as well. So we're going to have to figure out what's the right approach of what's the paradigm shift versus others, because some people, we can't endorse or recommend specific technologies. So it gets challenging sometimes. We get into rulemaking status in general of cost-benefit analyses. We'd love to say we'd love to require these operators to do X, Y, and Z technologies, but when you apply it across the board for the entire industry, anything's technically possible. Rick Cooperwitz has said it's not rocket science, so anything's technically possible. But when you get to, is it operationally feasible? Is it economically feasible? And that's where the discussion gets a little more interesting. So we're trying to figure out how we, again, advance safety, but we still have to follow the cost-benefit rules we have in place.
Thank you. Any responses or questions?
No, I thought the Max did a good job there, and his mention of the grade 3 leaks and repairing those, and most states and most utilities within those states have got very aggressive, and some of them have codes that you can't carry grade 3 leaks for more than 2 years or more than 3 years, and so there's a more aggressive pipe replacement program, because most of those were on cast iron, some of the older legacy plastic type, and so there's an aggressive replacement programs to replace a lot of that pipe and eliminate those, not just and these are non-hazardous leaks from a safety standpoint, but obviously from an environmental, they're still leaking gas to the atmosphere. So a lot of that's being resolved, and so that's a good thing. And then there's a lot of other utilities that have gone. They used to have an inspection on the downstream side, once every 3 years. Business districts where they had to leak survey them, once a year, for your bare steel or unprotected pipe, uncathodically protected was every 3 years, and then your plastics are cathodically protected every 5. And so a lot of people have gone to 3-year programs. So they're a lot more aggressive. They cover their system a lot more frequently, which is a good thing, from an inspection wise. And then now with advanced mobile technology and some of these technologies, they're even doing more surveys on top of compliance surveys for super emitter type things or continual inspections. So there's a lot more activity going on in the leak space that ever was done previously. So,
yeah, maybe just building on that discussion, I think Max mentioned, the grading system, and Paul was just speaking to it as well. I want to maybe make a broader comment on, as we're talking about how leaks are sort of managed and regulated, which is, I think, what we're all getting at here, and what's pretty widely recognized is that there's a real need for a paradigm shift in the way that we think about managing leaks on gas pipelines. Historically, this regulatory framework was designed around the idea that leaks on gas pipelines need to be managed from the perspective of safety incidents and explosions and ruptures. And that remains essential, right? And must continue. But there's now this recognition that any leak that's releasing methane consistently from a pipeline is contributing to climate change and is something that we need to address from essentially an air pollution perspective, right? And that's new in some ways as methane has become more widely recognized as such a potent greenhouse gas, but it's also really intrinsic for PHMSA, I think, as an agency whose mission includes protection of the environment and who sets, minimum pipeline safety standards that consider protection of the environment. So as we think about, the Section 113 rulemaking, I also just, am thinking more broadly that this is about sort of updating the way that leaks are managed and addressed to recognize that any enduring leak on a pipeline is, releasing something that's problematic for the environment and that needs to be found, fixed, and addressed as quickly as possible. And I think we're getting there, right? But normalizing that across the industry is so essential, and that's why I think this nationwide rulemaking is really important.
Thank you. I have one more question on 113, then we'll move on to section 114. I'm curious to hear PHMSA's perspective and maybe a little from Joe about how should we prioritize leaks? Should we prioritize super emitters? Should we go after every single leak? I'm really curious what your thoughts are on this.
That's a good question because, from an environmental perspective, you could argue, yeah, we should go after those super emitters because that's what's emitting the most into the atmosphere. But we're a safety-focused mission safety focus. So certainly prioritizing based on risk is also important as well. So, but again, I think shifting that paradigm shift, particularly, some of the distribution. Yeah, when you look at the stats, distribution probably doesn't have as much leakage as others. But there are things like leak-prone pipe and things like that, which we're addressing in other measures like the bipartisan infrastructure law, the bill grant that's mentioned out there. So a lot municipals are taking a certain advantage of that, and a lot of interest in it, by the way, which, thanks to Congress for giving us funding behind it, but we're finding the project needs are even much more than what we were originally given, but it's a good process as well to help that as well. So I think it is a balance of, maybe the super emitters, but also, again, still focusing on risk as well. But I agree, again, fully with Aaron, too. It does require a paradigm shift. I know there are some smaller operators out there, municipals, that they don't want to deal with leaks, period. So they fix them all. I also know it's a resource issue. So larger companies, it is a resource issue on can you really get after all of them without affecting resources from another program. So I think a little bit of both would be helpful, but it's just some initial thoughts.
Thank you.
I have a couple thoughts, two really. So one is, in general, I'm in favor of starting with a super emitter program. I think it makes sense that we should be targeting the largest leaks for most immediate repair. The second, but related to that, is this concern that that it's easy to say, oh, why do we worry about distribution system when upstream is where the most leaks are? Why are we worried about natural gas when cows are doing this, or rice? Why are we worried about the United States when China has all these emissions? So it's easy to fall into a logical fallacy where it's not my fault because someone else is worse. And so when we have to look at the valve in front of us, turn that valve down, and within the things that are under our direct control, focusing on super emitters makes sense. But let's not let the scope of super emitter allow us to not worry about the things that we are in direct control of. So that's one thought. The second one is, as these ALD technologies come online, I think it's more likely that we're going to find methane from natural gas sources that are not one of our traditional scopes, that it's not upstream, midstream, downstream, but I think we're going to see a lot more post-consumer gas that we're going to start observing. And one of the questions that then faces us is, what do we do about that? And I think, once again, it's going to be easy for a lot of groups to say, not my problem because it's not my gas, because I have my own list of things to worry about. And I'd like to start thinking about that a little bit preemptively to say, well, if a distribution company is selling gas to a home or business and a significant amount of the gas is leaving that home or business, the utility is likely the one who's best able to identify that there exists a problem and to at least inform that operator that they may be able to do something about it. So I want to just expand the scope of what we're thinking a little bit to include some of those post-meter sources.
Thank you. Let's move on to 114. As you guys know, we've got to minimize our methane releases. I'm curious, it's reached its effective date. What are operators doing now to mitigate their vented emissions outside of just creating these plans? Who wants to answer?
I guess as the operator up here, I should probably answer that one. So with Williams, what we did was, I guess it's maybe 3 years ago now, we made a climate commitment. And the climate commitment was really focused on kind of the near term. So a 2030 goal of reducing our emissions by 56%. A big part of getting there is focusing in on our methane footprint. we kind of view our methane emissions as something that really can be controlled mainly from day-to-day operations, whereas some of the more broader kind of scope 1 and scope 2 emissions issues are a little more capital intensive, or projects. It kind of gets a little bit beyond our frontline employees. So not only did we make a climate commitment, but this year we made it a part of our all-employee bonus program to reduce methane emissions over the previous 3-year average. So really, by doing that, it's created a lot of energy across our company around really getting those people that are closest to our valves and our pipes to be focusing in on how do we reduce emissions. And so when we looked at our footprint, probably over the last 4 or 5 years, the category that's consistently the highest was blowdowns. And we operate large 42-inch diameter pipelines that are operating at 1,000 psi. So there's a lot of gas in that pipe. So if you go and blow that down at pipeline pressure, it's a pretty large source of methane emissions. So kind of as what started as an experiment to see how it would impact the culture, we put in place in our operating procedures. We said if it's going to be 1 million cubic feet of gas in that blowdown, you're required to recompress it, basically reduce the pressure by 80%. And if not, like all other operating procedures we have in our management system, you have to get a vice president approval to vary from that. One good thing about culture is no one wants to go and ask their vice president for approval to deviate from an operating procedure. So we saw a lot of creativity in just how do we plan ahead, communicate across all of our areas to be able to recompress these. And what was interesting is even though we set that a threshold at 1 million cubic feet, because that was when we looked at our data, it's kind of that same 80-20 rule, like 20% of our blowdowns were making up 80% of our emissions. And that 1 million cubic feet was about a good threshold for those top emitters. We actually saw the culture of the company move towards always recompressing regardless of the size of that blowdown. So it's been a really interesting experiment. We're now kind of formalizing that into our company-wide operating procedures. So no, blowdowns are no longer our top category of methane emissions. So we actually are pretty proud to see how much that's gone down. And so then that kind of puts you on that cost curve of now what's the next category that we go after. So it's been a pretty interesting journey through that. And so that's not to diminish the concept of, we were just talking about leaks, but at the end of the day, those known vented emissions are really, that's the most controllable and easy to address from a day-to-day perspective. And then on top of that, we're putting in place all the advanced leak detection to try to find those super emitters and fix them quickly.
Thank you. All right. Are there efforts to go above and beyond just regulatory requirements here, particularly with mitigating vented emissions? Has anybody heard about new efforts being undertaken?
Yeah, I can address that. I think it's know your system and know your risks. If you've got areas where you've got, subsidence, you've got areas where you're earthquake prone, you got situations where you've got legacy plastics or older type of pipe. The idea is for the operator to understand their system, understand their pipe and some of the risk associated with their pipe. And rather than a prescriptive regulation, if they have to go out and survey that more frequently, because it is leak prone and risk prone, that's where I think more advanced leak detection technology is being involved, where utilities will go in or operators will go out there and leak survey their systems more frequently than it actually is what required by regulation, because they know there are potential risks for that until that pipe can ultimately be replaced. It could be frost. There's a number of different issues out there environmentally.
All right. I'm curious. We know that California has required blowdown mitigation for a few years. Do we know how this is going? Is it keeping methane in the pipe? And has it been cost effective?
I can speak a little bit. EDF has been engaged for some years with the implementation of SB 1371 in California, which required distribution companies and pipeline operators to implement a number of practices to mitigate methane emissions from their systems. And I don't have all my stats in front of me or at the forefront of my head, so will not even attempt to provide any numbers. But in general, what we've seen is some really sort of creative and innovative thinking from gas utilities in California, the way some of the programs under SB 1371 were structured, and the way that the California Public Utilities Commission approached that was to develop a number of best practices, and then to allow the utilities, some amount of leeway in the way that they implemented and achieved those best practices. And so what we found really interesting is that the annual reports filed by each utility about their methane abatement programs really provide just amazing detail, about the types of work practices and technologies that they're implementing, and, really good numeric reporting on the methane mitigation that they're achieving. And I think that's, a great model that we hope to see replicated elsewhere. And I will say, as a lawyer and not an engineer, I really enjoyed attempting to read some of the individual work practice documents and really understand sort of how things are being implemented on the ground, but think it's a great sort of source of progress. And again, hopefully it sort of serves as a helpful model for operators in other states as well.
Thank you. I understand the struggle, lawyer brain. All right. What about PHMSA? Are you guys going to issue a rulemaking on 114? Do you guys think your advisory opinion covers this? How have inspections been going for the plans for remediation and replacement?
I could start with the inspections first. Overall, they appear to be fairly positive. Linda seems like a nice person, but I can say she's been really on the regions to make sure we get our inspections completed by the end of this year. States are in a fairly good progress, except for, and I think it's fair to say even in some of our regions, but also states, the master meters, there's a ton of them out there. Some of these operators don't even know they're regulated by PHMSA, let alone what is this Section 114 thing. So there's some engagement pieces there we're working on. So it might be a chance the master meters will go into next year. The best available technologies report, we are working on completing that as soon as possible. I can't say what's in it yet either, because that's still internal review, but I think it's fair to say we will probably be showing a lot of information of what's already in the EPA natural gas STARC program and some of the others. As far as rulemakings, we believe, at least right now, at least some of the 5 that we have in play, like the rupture detection, helps a lot. Some of the others, we will certainly consider doing a rulemaking if it falls into the priority lists, if it's reasonable, things like that. So, based on the outcomes of the report, seeing how these other rulemakings go, we might have something else. I talked a little bit earlier about the complexities of having a rulemaking tied to specific best available technologies gets a little complicated. So we'll have to look at some of those angles as well. But I think overall it's going well, that at least from what I've seen and talking to some of our inspectors. A little plug, we also have a public meeting in Houston in a couple of weeks where we'll talk about some lessons learned, things like that. So you might hear directly from our inspectors on some of that. Greg Oaks in the central region will helping to lead that as well. So, and that will, I believe, be webcast. Yes, so we'll be webcast. Apologies on our behalf. We ideally would have liked to send these notices much sooner, but if anyone doesn't know, it takes a long time even to get Federal Register notices approved. So it will be webcast, though, so people can't make it to Houston in person. It will be webcast. And that is a public meeting open to all. So, yep.
Great. I want to ask the panelists if there's anything that I didn't ask them that they want to answer before I open it up to the Q&A from the audience. Erin? Yeah, I'd love to hear from you.
Just an unsolicited comment on Section 114, and no judgment on PHMSA or on Congress, just an observation. But, I think as we're talking about like 113 and 114 kind of in conjunction, I want to maybe remind us, Erin mentioned earlier that Section 114 came into effect, right, at the beginning of 2022, but what actually came into an effect was a requirement for operators to update their O&M plans, operations and maintenance plans, to incorporate measures to reduce methane emissions. But those plans are not filed. They're not available to the public. And PHMSA inspectors have been doing inspections and reviewing those plans over the course of this year. But I just say that I think it's a contrast to draw with like what I was just describing in California, where I'm reading these annual reports being filed by utilities and reading exactly what practices they're implementing and their numeric estimates of the methane emissions that they've decreased through the technologies and practices they're implementing. Section 114 isn't that, right? It's a good step forward because I think it starts to normalize sort of thinking about reducing methane emissions from an environmental as well as a safety perspective. But, that first step of it is really kind of preliminary. And I think, the steps to come, I'm excited to hear Max mention that PHMSA has a report that's going to be sort of summarizing what's come out of it, because I think that's going to be really valuable and sort of brings me to emphasizing sort of why I think the Section 113 nationwide advanced leak detection rulemaking is going to be so important.
Thank you. Anything else?
Yeah, and
Yeah.
I'll just add, I agree with what Aaron said. Still is a paradigm shift. Emissions is not necessarily leak detection, because even this Section 114 emissions report, people thought, oh, that's another leak detection report. No, it's not. It's something different. Leak detection does have a part in emissions, but it is reducing emissions. So yeah, I agree completely. That's kind of two different dynamics.
Great. We have questions from the audience. There is a mic, so I'd like somebody to bring one to any of these lovely participants. Raise your hands high and smile.
Hi, Virginia Palacios with
Thank
Commission
you.
Shift. Mark, I just had a question. The story about blowdowns is really interesting. It sounds like a success. Was it cost neutral or cost positive? What's the threshold at which you know that this is going to be beneficial from a cost perspective?
Yeah, nothing's cost positive in this world. So historically, the way we manage this, it's not new to reduce pressure before a blowdown. That's common practice. But historically, we had used the price of gas as the break-even point. And what we changed was, I think we were using worked out to be like $10 a ton of CO2. And that demonstrated in the grand scheme of things, from the cost curve of reducing emissions, $10 a ton is pretty reasonable. And I think if you were to look at a price of gas, if gas is $5, it probably comes out to $4 to $6 range dollars per metric ton of CO2. So we were going at a slightly higher cost, but at the end of the day, what we really found was when you plan ahead, and a lot of times the schedule on a blowdown, it takes time to recompress and draw down pressure. And when we did instant investigations on why did we have these 4 blowdowns at line pressure, it usually was a failure of communication internally and bad planning. So somehow, way or another, we wound up with operations requirement or a commercial requirement to get the line back up in service. And so by driving that communication, it really wasn't much of a cost to take that on. It's more just that pushing that planning. So.
Thanks for your question, Virginia.
Hello?
You're next. Or no. When you ask your question, if you could introduce your name and who you're associated with, that would be great for the people online. We're getting a mic.
Hello?
Got it.
He's behind.
Hi, my name is Robert Miller. I'm currently with Everline LLC out of Houston, and I'm a recovering regulator from the state of Arizona. My question is the bullet number 3, where it applies to the entire 2.8 million miles. I don't see there where liquefied petroleum gas. Is that included in this 2.8 million? Because I see it's not listed as LNG is separately.
So our current inspection approach for 114, if it's a natural gas, and Linda, correct me if I'm wrong, if it's a natural gas facility that helps feed a liquid facility as well, then that's considered part of our inspections. I will say we are looking at the next stage of, do we need to look at the entire pipeline system? That gets really interesting and complicated, and I'm sure industry will have some comments on that, whether we can go there, but that's at least the current approach now. So in a way, yes, it applies to the entire system, but it depends.
Hello, my name is Scott Eustace. I'm a Healthy Golf. We're a 26-year-old environmental nonprofit from Texas to Florida. And my question was, is there any planning anticipated in the need for more labor after hurricanes? I ask because, you know, I'm not trained in leak detection, but if we flew after Ida, for example, just a couple of Cessna flights and filed 20 NRC reports of oil on water from different infrastructure in the coastal zone. Sempra Cameron LNG, you know, their 2020 benzene emissions, 1/3 of those were unplanned. And I imagine that was due to Hurricane Laura, which hit them pretty hard. So you know, what we see is the Coast Guard has ramped up, but they're still a bit overwhelmed. Our state agencies don't, and often, you know, they don't have boats in an area where we have a lot of these pipelines underwater. So is there any thought of like working with Coast Guard or say civilian air patrol that has a lot of, you know, airplane capacity after disasters to speed up the rate of inspection after predictable geohazards?
I can't specifically speak on the liquid side, but I can on the natural gas side is there is mutual agreements. I know the American Gas Association, several of the trade associations have mutual agreements. So if there are catastrophic incidents like that, the various utilities or operators will supply people to leave their facilities and drive to wherever the affected area is with technology, with vehicles, you know, with portable equipment. You got to remember these people are operator qualified too. So you just can't take a non-operator qualified person and put them out doing some of these inspections. So through some of this mutual assistance that has worked extremely well through some of these major catastrophic incidents, they can deploy. You just saw what happened in Florida, just with the electric and power companies and stuff that, you know, relocated in a very short period of time. And so that works well. I mean, you can't be every inch of pipe, you know, as quick as you'd like to, but we certainly can get the resources and the equipment in those areas. A lot of it has to do with, and even on the natural gas side, you know, when houses get disrupted off their foundations because of earth and pipes are broken, you know, it's a lot of the debris fields and stuff. And so there's a lot of advanced leak detection with standoff laser technology, with advanced mobile vehicles that are more sensitive, that can pick up some of these leak indications, you know, and so a lot of those are driven, you know, in these hurricane affected areas to get in there quickly. You know, utility can't shut off the gas in those areas. If they depressurize that gas, then all the lines fill up with water, you know, from the tidal surge and stuff. And now we got even a bigger problem, you know, and so that's why the key is to get out there quickly and find these situations and cap these off, these large leaks.
Hi, everyone. Joe Nye. I'm with the Office of Information and Regulatory Affairs at the White House, and I'm the PHMSA desk officer. So I just full disclosure, but I wanted to ask a question about what we know about the baseline right now, specifically about like both leak detection and emissions detection systems that are in use by the industry. How much variability is there in the types of systems that are used? What percent saturation are we seeing across the industry? Is there one system being predominantly used? Are there multiple? And sort of how are you all keeping track of that?
Thank you.
So I'm here for.
I honestly don't know if we have the data collected on that. I know our folks, Office of Planning Analytics, they look at the economic impacts of or approaches the markets on some of these as well. I will also say we're often limited in getting too much into details of some of the specific technologies because it does get into antitrust concerns and things like that. As an overall market trend, I don't know if I have honestly those specific questions right now, but feel free to reach out to us and we'll get with our OPA folks and some of the others. Yeah.
Yeah, I'll add a little to it after I pointed the question to you. I feel like I wear a lot of hats these days. One of them is working with National Petroleum Council. So the NPC is currently doing a study that is covering the greenhouse gas emissions across the entire natural gas value chain. Part of that, I think the first section of that is baseline. What's the current technologies being used? What are the policies in place? What trajectory does that put the overall greenhouse gas emissions footprint on? And then taking that all the way through kind of where are we going? What additional technology needs are there? And I'm sure a whole host of other things. So that's will be my extracurricular activity for the next 12 months or so.
And I'll just add to one, as I thought about it too, I know we are getting creative or trying to get creative on cost benefit analyses. So there have been some executives orders out there, for instance, looking at the social cost of carbon and things like that. So that alone could get really interesting with some of these rules. We anticipate there will probably be some disagreements on some of the numbers, but hey, it's cost benefit. We always have disagreements on or not disagreements, creative discussions on those. So things like that are coming up too. And again, this is a full administration perspective on agencies working together to see how we collectively address some of these issues. So those are things like that that are coming up, is what's the social cost of carbon, which gets really interesting. So, yep.
And I'll add, Paul and I were discussing a couple aspects of this, but one is that advanced leak detection is seeing greater and greater market saturation in a variety of ways. It comes in a couple of ways. One, companies can purchase the devices, and that becomes a capital asset, which they're able to pay for. That's becoming more common. Second, there are a number of device operators, sources that are coming online, and it seems like there's another one or two every year, which reflects both the growth of the market and its increasing depth of saturation. Colorado State University operates METEC, which is the methane emissions testing facility, where a number of technology providers come to test and demonstrate the effectiveness of their technologies, creating that sort of nutrition label information I was talking about earlier. The Gas Technology Institute, among other places, provides that. There are a number of ways that we might be able to try to get you some of the information about saturation if you'd like more about that.
Yeah, and most operators today have training facilities, or what they call, leak fields, where they simulate, they can create leaks to train their own people on to operate, qualify their people. Instead of going out in the field and do it, they just simulate, create live leaks within systems. And most of all the leak detection technology, just because ABC company's using it and ABC likes it, doesn't mean every other operator, feels the same way. And so each operator tends to scrutinize each piece of equipment before it's approved through their engineering team to come into their facility. They take it out on these and it's basically show us, and let's go out and I've got a number of leaks out here of different sizes, and I want you to go find them. And so there's double blind studies and stuff to prove it out. Even though you may have white paper after white paper of all these studies, most operators still want to go out and see it themselves within their own system. So,
Thank you. I think I'm getting a signal that there's a question in the back.
Yes, Dante Swinton, Center for International Environmental Law. Mark, I believe you mentioned that you had a climate goal, and I was hoping you could repeat that in terms of the amount of reductions and the percentage compared to whatever baseline level you were talking about earlier. But also, since you're part of the NPC, I'm curious to hear if there are either weaker, as aggressive, or more aggressive climate goals that these companies have in terms of reducing their methane emissions as well as their CO2 emissions, and if you could shed some light on that.
Yep, sure thing. Our commitment is a 56% reduction from our 2005 baseline, and we hope to achieve that by 2030 or sooner. It's an absolute goal, and I think what we're seeing pretty often across industry is a lot of intensity-based goals. So as companies, we're in the business of growing our business, growing throughputs, increasing capacity. So a lot of people have used intensity-based metrics. It's similar to One Future, which is our nation's energy future, which was set up on a methane intensity goal across everything from the wellhead to the burner tip, trying to achieve a 1% or less goal. So I think there's goals all over the place, but I think what we're seeing is a lot of 2030 type timeframes to 2050, and then baselines are starting to kind of move up some. And I think that's one thing a lot of companies are looking at, is keeping the baseline to be something meaningful, to continuously pushing for further reductions.
Thank you so much. I've been told that we need to end our session, but I want to thank our panelists for joining us, and I want to thank everybody for attending the session today. Thank you so much. Thank you for volunteering. I really appreciate the time investment and everything.
It was great to be here.
Good. And Aaron's probably running to another panel. Thank you very much.
We're going to get our next session started. Folks should find their ways to their seats. Sorry, I was not paying attention to my list. Oh, do I need to get your PowerPoint up? I'm failing all around. I'll be right back. Please find your seats. I don't know if you were in the last session. This is so touchy. You might want to just test it out and get a feel for it. Please find your seats. I don't know if it's like censored or what, but it just kept advancing at the end. I don't know what was going on. All right, we're going to get our next session going. In-home methane methane leak detection, a case study. Oscar Leon is going to be leading the session.
Oh, sorry. Yeah.
Are we-
4:05 on here. 3 o'clock.
Uh-oh. I have 250. I think there might be an updated. Sorry, we're working out updated agendas.
Oh, so okay. So then how the federal pipeline agencies is going on right now then too?
In this room, we have in-home methane leak detection, and then in the other room, there is PHMSA Community Liaison Program in the Royal Salon.
Okay, cool. Thank you for that. That was very
No, yeah, I think there's been a couple of versions. Yeah. Okay, we're going to go ahead and get started. And just as a reminder, if folks are listening online, you can submit questions to questions@pstrust or pstrust.org. And if folks feel comfortable moving to the front, definitely feel free to do so. Fill in the front a little bit more. So I'll go ahead and I'll turn it over to Oscar. Thank you so much for joining the panel.
Okay, thank you, Beth, and good afternoon, everyone. And as I say that, it started to change slides on its own. Okay, I think we'll be okay, though. Excited to talk to you this afternoon about our natural gas detectors. My name is Oscar Leon, Department Manager of the Gas Emergency Response Center at Con Edison of New York. And just to bore you a little bit of what I'm responsible for at the company, it's basically emergency response training to our local first responders, including the fire department. Also internally, we're also responsible for notifications and the managing of emergency leak coordination, et cetera. So anytime there are issues of emergencies, basically comes through me, and we do our best to mitigate the emergency so that way it doesn't get out of control. Specific to this project, I was part of a cross-functional team that consisted of a lot of individuals. And my role in it was the implementation piece. So in October of 2018, after all of the research and R&D, which was extensive, happened, came over to myself and my team to basically implement it and work with the boots on the ground to solicit feedback, not only from our internal folks, but also from local fire department and the public outreach that occurred prior to implementation. So I'd like to start off with the why. So why did we implement in-home methane leak detection or natural gas detectors? Unfortunately, it was due to these two catastrophic events that happened, as I'm sure you're all familiar with. On the left, come on, behave for me. East Harlem, the unfortunate event that happened in 2014. 2 buildings collapsed, 8 people died, and a very large number of injuries occurred as well. And that had to do with the migration of gas from outside of the building to the inside that led to an explosion. And then on the right, the East Village explosion that happened the following year, unfortunately the same month, ironically, that had to do with an illegal tap, illegal pipe work going on that led to 2 buildings being engulfed in flames and 2 fatalities and numerous injuries as well. So that triggered a way to for us to get better. And just a deeper dive into East Harlem. The moral of the story is that the company was not aware of a gas odor until 15 minutes prior to the explosion, right? And then post-investigation revealed that there were quite a number of people that smelled gas for a number of days, but it went on without it being reported. And so how do we prevent people smelling gas that doesn't go reported? So obviously, traditionally, the way it has worked until the natural gas detector point is, you smell gas, you evacuate, and you report it, and we respond to it, right? Unfortunately, it doesn't always happen that way. Even with the public outreach and the extensive messages that we provide the public, whether it be through scratch and sniffs and the bills, the commercials, or the advertisements. There's a lot of assumption going on. Well, people feel time pressure as well. You don't have time to call the company. Somebody else will do it. Or yes, we're aware. Or for some odd reason, this convincing of yourself that it's a controlled way of natural gas to behave, and it's not. So how do we protect against that? Which brings us to our natural gas detector. So this is the natural gas detector. Okay, that's the natural gas detector. So it's pretty much a spec sheet. I'll sum it up for you. So it is a device that works in conjunction with our advanced metering infrastructure. Basically, in layman's terms, or the way that I like to describe it, is our own Wi-Fi network, our own company Wi-Fi network that we use, leveraging that technology in order to make this technology work. And what it is, it's a pairing up way of activating this device. So we have this device that's able to connect to our AMI network. And then once that happens, the threshold that this device activates is 10% of the LEL. It's a very sensitive setting. So anytime that device, which is always censoring for methane, by the way, detects 10% of the LEL or more, it alarms locally. There is a message that it tells the person, whatever occupant that's there, to evacuate. And then while that's happening, it sends a message, come on now, to our control room without any interaction from the customer at all. So it does not require a customer to call the company in order for the company to realize that there is a gas emergency at that location. All right, so going back to East Harlem, we have found a solution for that. However, there is an education piece, the installation part of this device. We still encourage the customer to call. Please don't have an overconfidence with this device. While technology is great, while what? While it works. Exactly. So please don't find yourself in an over-reliance state with this specific device. So if you smell gas, continue to call Con Ed, even though this thing is alarming locally at your place. So this is pretty much just a general overview of the timeline, right? 2016 is when extensive research was going on with the GTI, a lot of R&D, trying to figure out what this device was about. Was it even feasible for us to implement in our own service territory, and how would we do that? And then the 2018 portion of it is where I came in, and really under the 2020 piece was the mass deployment. But even prior to that, there was an education piece to stakeholders such as the fire department and public outreach and our own internal folks as well, right? Because as we all know in the gas industry, we love change. We love doing things different. That was a joke that played a lot funnier in my head, by the way. So no, we like to do things the same way we've done it for years, right? So that part, that people part, and educating our own folks was the biggest lift. You know, what is this new way of responding to gas leaks? So responding, this is just another illustration of what I mentioned before, right? So the natural gas detector would alarm locally at the location. It would alarm the control room, and then the fire department and our local first responders would go out to that location in parallel. That part, in order to get to that part, really the technology piece, right, was very extensive, as I mentioned, but was the people analytics portion of it was very difficult, right? To have that conversation internally with our folks that for some reason we have this comforting feeling to respond to the unknown. But meanwhile, this device is actually telling us that we're responding to an actual gas leak. So that psychological piece required a lot of patience and town halls internally with our folks, and also with the fire department. So the internal and the external communication piece was huge. A major concern specifically for the fire department, as we met with their senior leadership, was, false alarms, right? Naturally, you compare this device to a smoke detector or a CO detector. In New York City, per senior leadership of the FDNY, there's over 100,000 false alarms that they respond to in smoke and CO detectors. So, here comes Con Ed with a device that looks very similar. And it was our job to not only receive and absorb their feedback, but also to provide them with data that suggests that this piece of technology is much more sophisticated than your normal smoke or CO detector. The technology involved with it basically suggests that it would only alarm when it detects a gas leak. You will not see lights for low batteries. You will not hear anything for any sort of other defects with the device. The only time you would see a light or hear the device operate is when a gas leak occurs. And one of the milestone moments that I had with the chief of operations of the FDNY, and as what I felt that we basically were able to obtain their full endorsement, was with Chief Sudnick, who is a very intimidating individual. Because not only is he very, very tall, but he's also a person that is responsible for a lot in New York City, and was very skeptical about this device for very good reason, obviously, because so were we. This isn't anything we've ever done before, and we could be potentially, asking for trouble because of not only an implementation of a new piece of technology, but also our own resource constraints as well, right? So we already respond to about 50,000 gas order calls a year in our service territory. This could potentially, warp that number because we didn't know. But through extensive research and studies, that is not the case. And we had a meeting with the chief of operations, and this was after the probably 10th or 12th meeting with him. He turned over to his right-hand person and basically said out loud, as we were across his table, that we need this for public safety. So he was thoroughly convinced, and so are we, that this was something that we needed to do. We also went through how would these devices be installed, right? And these devices are not installed in customers' apartments or in kitchens. This is strictly at the point of entry from where the gas service comes into a building. Again, going back to East Harlem, the migration of gas into the inside foundation wall from the outside. That's the intention, to be able to capture that as natural gas is migrating into the building. So in the yellow circles, you'll see the natural gas detectors. That's how they look like. Above the point of entry, that's towards the bottom of every one of those pictures. And within that picture, you'll also see a tag. That's the warning tag. And it's in several languages, and it instructs the customer and provides information about the device, but also instructs the customer that if you hear this device go off, please evacuate. And obviously, this is something that is verbally communicated to the customer in the installation process as well. We don't just leave it up to the customer to figure that out on their own. All right, so this is some information on our deployment schedule. So we spent about $70 million to date. And our forecast of total through 2025, which is when we expect to have a full implementation and installation throughout our service territory, which is 370,000 units, is $175 million. When I created this slide, we had about 147,000 units installed. That number is at about 160,000 now. Another visual depiction of the types of leaks that we have found And to date, we've had about 1,500 leaks since October of 2018, which was the pilot till now. And pretty much what this tells me and what this tells you is that the device works. Out of the 1,500 alarms that we have received, there was only one false alarm. And the division of what you see is inside leaks, outside leaks, residual gas. So one of the things, right, that you go into when you do something new is that you have the intended outcome and the actual outcome, right? There's a lot of this information also shows what we didn't anticipate, right? And I'll talk about that a little more as we go on, but the unauthorized pipe work that occurred in East Village. Very ironic story. I want to say funny story, but it's not funny, but at the moment it was, was that in the pilot program in 2018, we had installed this device at one of the locations, and we received an alarm at the control room, send the local fire department, as well as our resources to investigate this alarm. As we get to the location, we discovered that it wasn't a gas leak that was the reason that the alarm sounded or was activated. It was because a plumber was illegally jumping out pipes. And when the plumber turned around, there were about 15 firefighters behind them. And so that ended quickly. And wasn't the first and only time that this device have caught those actions in place. So unintended result, but very favorable. And these are examples of the inside pipe leaks that we have also discovered as a result of this program. Again, unintended result. We didn't expect to find leaks on piping. Going back to East Harlem, once again, I know I sound like a broken record, but the intention is to find gas migrating from the outside to the inside. But we're also finding leaks on pipes inside the building. And so while they may seem minor, leak is a leak, right? And so we're catching them at the moment of inception. That is minor at the moment, or at the moment that it alarmed. But you don't know what that leak can lead to, right? It can grow over time. And as I go in through this presentation, I'm going to go into some examples to demonstrate what we have found. So there you have the POE circled in red, right? So at the onset of this program, we thought about everything, right? We looked at data so many different ways to try to give us an idea of how these devices would activate and what we would encounter in order to not only to prepare ourselves for what was coming, but just to get an overall better understanding of the device itself. So if you remember from the previous slides, the installation, right? The device is above the point of entry, right? So not every basement is built equal, okay? So we have a lot of interesting basements in New York City. So we weren't able to install this device above the POE for several reasons. But we were able to install it, at least in the vicinity, 6 feet from the POE. As we received this alarm, we encountered a grade 1 or type 1 leak, which is the highest severity leak. So natural gas migrated all the way through the other side of this room here and activated the device to notify us of this type 1 leak, right? Again, we weren't expecting that. And then as the program went on, we ended up not only understanding a lot more of the installation piece of it, but a lot more of the habits of how natural gas moves inside structures. So here is another case study that we encountered in Westchester County in New York of a discovery of a cracked main on a 4-inch low pressure cracked main from 1900. Yes, we still have those in New York. So we received an alarm at about 2 o'clock in the morning for 125 Oakley, right above where it says Oakley. That's the initial alarm. We get there and we found 2% at the inside foundation wall, which is a grade 1 highest classification. Naturally, our investigation process calls for us to check the adjacent buildings and also the building across the street. As we were doing that, we had a second alarm go off next door. So as we were investigating, the natural gas detectors were actually assisting us in our investigation as it was going on, and we found a cracked main because of these devices activating. This was the most recent and significant case study that we had in September 26th of this year. Once again, it was at 3 a.m. natural gas detector activation in New York City, 10 West 32nd Street. It alarmed at a hotel. We detected readings of 5% of natural gas in the atmosphere of a meter room. The fascinating thing of this case study is that it wasn't the gas reading that activated the natural gas detector. It was the burnout gases from an electric cable that burned out at the same location. So another discovery of these natural gas detectors is that it actually activates due to burnout gases from underground buried electric cable. That burned out electric cable burned through the surface of the hotel, causing the atmospheric gas reading. And it's not to say that we would not have found out of that gas leak there, but I can assure you we would not have found out that soon had it not been for the natural gas detectors. So other learned GLA experiences, I mentioned the illegal pipe work. They also activate from fires. Quite a number of times we've responded to building fires before the local fire department, or we actually call them after we arrive due to our natural gas detector activation, and we would call them and say, hey, this isn't a leak, this is a fire. The methane found within the carbon monoxide of a fire actually activates the natural gas detectors as well. There's also something about heavy rains that activates the natural gas detectors as well. So during Hurricane Ida, we had an influx of GLA alarms. We're still investigating as to why exactly it happened. We believe it has something to do with precipitation and barometric pressure. But on average, just to give you a sense, we respond to about 150 odor calls in a 24-hour period. During Ida, that number increased to 700, and 200 of those were GLAs. So anytime we have a lot of rain in the system, it activates these GLAs as well. So we have some key takeaways. I won't bore you with going through every single one of these. We've already discussed them in the presentation. But one thing that I do want to point out is that, yes, this is a reactive device. It activates once it detects a leak. But there is a proactive side to it that I can tell you because I live it every day. And that is that these devices activate at the inception of a gas leak. Going back to the case study I had with 10 West 32nd Street, it's not the only case study that we've encountered prior to a smaller leak growing to a significant leak. We're getting there right before these gas leaks get to a really, really dangerous state. So I fully believe in it. And this isn't something that we're implementing blindly. We're still learning from our implementation. Anywhere we can get better, we're making adjustments as we go along. We've also had industry recognition as well. You know, AGA, NGA, all the GAs, and everyone that have basically provided us a lot of support on the implementation of these devices. And that's all I have. If there are any questions.
My name is Glenn Archambault. I'm
How you
from
doing,
Jackson County, Oregon. I follow gas leaks and ignition day to day. And so looking at this, a question I have for you, do we have an average time from the start of a leak to the point where we have a really dangerous mix? Or is that always different?
Yeah, it all goes back to the previous discussion. Not every leak's the same. That is from Japan, by the way, to see if we can obtain, so we can leverage the technology within the device to provide us information along the lines of what you're asking. You know, if it's monitoring and sensing, which it is all the time, can we use the data once it activates for a gas leak to tell us more about?
Hi, Graham Emerson with Enbridge to detect with these. Any success stories with crossbores?
Yeah, the successes we were able to reach, thankfully, few and far between, where we've had. Thankfully, because of these devices, we were able to get there right on time. And there have been cases where we've discovered damages that were buried by local contractors.
Or are you blanketing?
Yeah, so when we first started, or residential, but after a point, I mean, after the experience we've had with this and the confidence level grew, we just. Oh, okay. All right. So if there are any other questions,
They got all the technical difficulties figured out on this.
I think, you know, as long as everybody's plugged in.
I was going to warn everybody that these mics are all live, no matter what you choose.
Oh.
I was making some comments earlier Nothing too bad.
So I hear there are mics in the back.
Yeah.
Yeah, right.
Okay, right on. Yeah, sorry to interrupt this one. Having said that, something like that. Yes. Presentation. Well, I just did that in it. It's not for me to have it around. Long as fizzy water.
Hello, hello. If everyone could sit down, this session's going to start in 2 minutes. Thank you. 2 minutes, please sit down. All right, we're going to start this session in 1 minute. So please take your seats or go to the session downstairs. Thank you.
Okay. So how are we advancing those?
I'm gonna make.
So you can
Is there a
see.
clicker?
I think this is the advancer.
Okay.
I'm not sure. And I know that they've been advancing when people don't want them to. Which is weird.
Yeah, Mark had that problem downstairs. He had animation.
Oh, I'm sorry. I can go over there.
Oh, yeah. Yeah, no,
Is that about that short?
You're right. You're right. I was like, should I be smiling? I don't know what you're trying to say.
Hi, timely people. We're going to start. Welcome to the session on data. I'm honored to moderate the session where we're going to discuss the uses of data to promote pipeline safety. I'm very excited for the session because in addition to serving on the board of the Pipeline Safety Trust and being an engineer, I'm currently taking a course on data visualization. These guys know a lot more about it than I do, but I'm very happy to learn from them. So to start, I also want to acknowledge the Indigenous people who have stewarded the lands where we are meeting today. So earlier today, the National Transportation Safety Board Chair, Jennifer Hamady, said, and I'll paraphrase, that focusing on accidents and incidents alone may prevent discovering safety solutions. Her point was that we need to understand what is being done right as well as what went wrong. And by focusing on incidents alone, we are learning things after the fact. This session will cover how data, including data not now reported and provided to the public, can help reduce incidents. So the three presenters here today are Graham Emerson from Canada. He's going to introduce what industry is doing on data. Blaine Keener from PHMSA in DC. He will cover PHMSA's efforts to use data to address equity concerns. And James Eager with the Trust will present the work he's been pulling together to make data understandable and usable for the public. The session's going to have some interactivity, so we're going to have maybe somewhat shorter presentations, and then everyone in the audience will be able to ask questions to see whether there are capabilities that are either exist or may soon exist to answer data questions. We want to hear your ideas about what data you want to see and what data can help with preventing incidents, not just documenting them after the fact. So thanks to the presenters, and Graham, you're up.
If I close this, is it a problem? I can still close it. All right, I'll just shut that. Perfect. Yeah. All right. Okay. All right. It's getting on 4 o'clock. We're all in New Orleans, so I can tell this is the group that truly cares about pipeline safety because you're all still here. So thank you first and foremost for sticking around. I've been doing, pipeline safety analysis in one form or another for about 16 years now. And honestly, what we're going to talk about today is really just scratching the surface on pipeline safety analysis and the data that's necessary, but it addresses what I found to be a persistent problem, which is just the general lack of standardization compared to other industries and how we treat incident data. And so that's kind of what we're going to get into here. Before I do, in pulling this together, I just did, a rudimentary Google search on, are pipelines safe? Because I wanted to see, kind of the data that's currently dominating the public pipeline, safety discourse. You can see these are all just cut and paste off page one, but right off the top, we've got comments that spills and leaks and ruptures are rare. They're a tiny percentage of throughput. Other comments, talk about the alternatives. Pipelines are the safest alternative. Then there's the but argument, which is pipelines are generally safe, but incidents happen. And then other perspectives that pipelines aren't safe because incidents happen. And whether you believe spills are rare or you believe they happen all the time, the core of all these pipeline safety perspectives is incidents. And when you uncover it, there's really only one source for that data, which is operating companies themselves. They're the ones, having the incidents. They're the ones reporting to regulators. The regulators are making things public. The operators are reporting these incidents on their own web pages, so on and so forth. It all comes down to the operator's data. And so this is what has kind of led to the standardization efforts, is trying to get, industry treating their incident data and using it to reflect on performance the same way. Over the past, I would say 10 years, there's been, a number of really focused efforts to try and get this data, I don't know, all on the same page, if you will. It seems really trivial to focus this much effort on just, what should be a simple naming exercise or bucketing exercise. But it's actually a real impediment to not be speaking the same language when it comes to the severity and the frequency of incident releases. In terms of what even defines an incident, go jurisdiction by jurisdictions. The regulators all have different views. And so you can't really compare across jurisdictions if you were to adopt one incident definition versus another. The operator's choice of metrics are probably maybe a little too opaque for public reporting and have been too inconsistent over time. And, the investment community has, they take a great deal of interest in whether operators are risking their money and taking on greater risk in the future liability. And so, they themselves are probably one of the biggest drivers for standardization, because you have all the investment indices, the ESG analysis, a plethora of organizations looking for information and all asking for the exact same data 1,000 different ways. And it was really, that as probably the driver for kind of a seed group of, companies to come together, working with industry associations and CSA to, try and write the first standard. So that was a CSA Z260 standard. It was published in 2019, and admittedly, it didn't get a lot of play in the US. And without the US market, it wasn't going to take hold. Now, fortunately, API had been working with that committee since the very beginning, and I'm really happy to say that API and CSA, competitors, are working together on their first joint standard for process safety metrics for the midstream operations. Okay, it's under development, and this is frankly my glorified infomercial for that standard. It's important to have these standards because pipeline safety, or process safety, if you will, it's a technical field, and with that comes a lot of jargon. So if you ask a simple question like, are pipelines safe? You're going to get a nuanced answer, like, they're the safest alternative, or well, incidents are down this year, but volumes are up. But next year, we're steadily getting better. You'll get answers like that, or even if you got a simple, straightforward answer like yes, you just may not find it credible. And so, at the root of this is the fact that in these pipeline safety discourses, we can't communicate clearly and without a great deal of effort unless we're speaking the same language. These are meant to be objective and fact-based discussions. And so again, that's where that common language comes into play. It's the cornerstone for that open discourse. Once you establish that objective lens, then you get greater use. More companies start, adopting a methodology, reporting to it, more data becomes available. Because it's standardized, it becomes that much more transparent, and it grows. And so that was the purpose of the API 1186 CSA Z260 standardization effort. It was to create this common lexicon for pipeline safety. This is really the only slide with content from the standard, because it pretty much sums it all up. It is meant to be simple nomenclature for metrics and classifying events. Okay. The metrics themselves are just, the counts of the different bucketed events. And so, by simple and objective nomenclature, it's a simple 1, 2, 3, 4, not applying any other labels to the categories. But you start with tier 1. These are loss of primary containment events, leaks of greater consequences. Okay, these are everything from a fairly, I don't want to say routine, but a leak that could be uniformly defined to be consequential, like 10 barrels or 100 barrels or more, up to the catastrophic type events. Okay, it's a very wide band, and intentionally so. Your tier 2 are these LOPC events of lesser consequence. They are the ones that are not going to make headlines, but they're ones that need to be captured, need to be investigated, need to be learned from. Tier 3 are any of those leaks that just are still too small to even fall into that tier 2 category, and all near misses. Anytime a safety system has to activate in response to an abnormal event, these are all tier 3 events. Tier 4, these are way down to the leading indicators when you start using them as metrics, but these are excursions from your operating procedures. These are non-conformances. They are indications that, okay, something has gone awry and it needs to be looked at. And so, the meaningfulness, because we've talked about, I think at every pipeline safety trust conference I've been to, meaningful metrics and, the need to be able to maybe get predictive. Well, the meaningfulness comes from the fact that, one, these are harm-based categories. Okay. Volume is in consideration, but largely the categorization is based on actual tangible harms, fatalities, oil and water, fires. Okay. And the other part of the meaningfulness comes from the fact that, especially in the tier 3 and tier 4 range, every single event that gets categorized towards these metrics is something that is causal in nature. Okay. A tier 4 indicator could be missed inspections. Well, not any missed inspections. It's missed inspections because these are the things that, are critical safety controls. They are inspections that really had to happen. And so, that causality and this focus on the safety controls that are preventing leaks is what makes those leading indicators truly leading. Because, if you've got abnormal events that keep happening and happening and happening, and you're not taking action to step in and correct them, then you're going to have more accidents. And so it's that causality that really, really makes the difference between, an indicator that's just an artifact of your management systems and something that's truly related and causal in incidents. I mentioned that, these are predominantly harms-based categorization, fatalities, injuries, fires, contamination. Okay. And, that is because volumes, they're difficult to understand, frankly. They don't have a lot of true impact. They're not necessarily a sign of risk realized, whereas these harms-based events, they are risk realized. Okay, I'm getting the flag here, so I have 2 minutes to step forward. So I'm good. That's probably enough on the content of the standard itself. There's Enbridge was an early adopter of this standardization approach, and I have to say we've gotten a lot of leverage out of it. We use these relatively small number of safety metrics, to be a mainstay of our reporting to senior leadership and the board. They tell us ultimately the performance of our operations, how we're doing. They tell us the performance of our programs and our management system. And that's really just even the tier 1s and tier 2s. We also use them as, within the management system itself. They give us something to base the procedures on, so we can set our investigation efforts commensurate with, the tiers, if you will. And that investigative rigor, when it's on the right opportunities for learning, your higher tier events, then it gives you a lot of data on what went wrong. And also gives you a lot of information for your process safety engineers to analyze and constantly and then look to see, okay, where are our controls a little weaker than they should be, and so on and so forth. It gives you something for benchmarking, and benchmarking in itself is it's nice to have. It really provides some motivation for companies to try and be the best. But the real thing about benchmarking is, once an industry association or someone steps up to launch benchmarking, then the entire membership adopts that way of speaking, that framework overnight. And it accelerates adoption of best practices. It also gets the conversation going amongst operators, because you sit down at the table and you're all going to talk about your tier 1 events, and you're going to share those learnings. And so we're not quite there yet. Certainly other high hazard industries do a lot more to support each other as companies, with assurance activities, with benchmarking, with industry performance metrics. And so, for us to get there, the first thing we've got to do is, I hope, pass the standard. It will be coming out before the end of the year for public review, and I hope everyone does take a chance to comment, and at least read it, because it's our first step. The next thing, as I mentioned, is benchmarking, and it's to increase and accelerate the adoption. I'd like to see adoption by industry associations. If we have API and CSA on board, that there's other associations that hopefully will follow suit. I'd like to see the regulators start using the standard and speaking the same language as the rest of industry. That's not to say adoption in regulation. And then the final thing is we got to keep the standard ever fresh. And for that, we've got to know, what's the next source of information? What are the next questions that industry and the public are looking for? So I'm going to turn it back here because I think we're going to just answer this question later or now.
Yeah, I think because we want to get to the interactive portion. Sorry.
Yeah.
Can you guys hear me? And we're going to need a little time to switch computers. We'll just keep going, and then we'll have questions. Thanks, Graham.
All right, so can I get my slides, please? Thank you. So the Office of Pipeline Safety within PHMSA has been looking at social equity pretty much along with DOT, the other modes, and most of the federal government for the past few years during the Biden administration. So I wanted to give you an update on where we are with our social equity projects. Am I supposed to advance? What do I point at? There we go. So a little bit of evolution. We haven't been at it that long, but there's been some significant changes. Back in 2021, we looked for GIS layers that we could marry up our incident data with. And DOT was recommending the Social Vulnerability Index data that was available from the Center for Disease Control. And they recommended that we use a very narrow band for high vulnerability from 0.9 to 1. And so we did it with our gas distribution incident data. And what we found out was that for the minority and language SVI, only 2.3% of the nation had that high vulnerability. And there was an annual average of 11 gas distribution incidents in those high vulnerability areas. So we decided that we really, we were a little leery about that because it's a very small part of the nation, a very low number of incidents. And then early in 2022, DOT came up with a replacement for the CDC's SVI layers, an interim DOT definition of a transportation disadvantaged community. And in that definition, it's a blended definition that uses 6 different transportation disadvantaged categories. And when we grabbed hold of that and started using it, we found that 30% of the nation is considered disadvantaged. And we had an annual average of 32 gas distribution incidents annually in that 30% of the nation. So it made us a little more comfortable in proceeding because it was a bigger chunk of the nation and captured some more of the incidents that were of use. Yeah, and now, sorry, since my lid got closed, my VPN dropped. I'm looking ahead here, trying to get ready. It's all right. I didn't think people would be here at the podium before me. So here's the 4 projects we've got planned. We're doing the gas distribution incidents. We're doing our excavation damage incidents, and that's for all system types. And then for gas transmission and hazardous liquid, the analysis is going to be a little different because we actually have mileage data to go with our gas transmission incidents and our hazardous liquid accidents. So when we do those 2 projects, we'll actually be generating an incident per mile rate, both in disadvantaged communities and in non-disadvantaged communities. For all those, we're going to be running calendar year 2012 through 2021 incident data. And the motivation there, we want to do the most recent 10 years of data for our incidents. Getting warmer. So the project components, so 4 projects, and each of them is going to have a GIS tool, which I'm hoping going to be able to demo for you at least 2 of those tools that allows you to visualize the incident locations. You can zoom to a state. You can access data about the layers that are in the tools, and filter by pipeline operator, filter by incident cause. The other thing that we are including is a spreadsheet so that stakeholders can do their own analysis of the data. So we're showing it to you in a GIS tool, but you will also be able to access the data so you can do whatever you want with the data. Getting warmer. So our future plan. So I covered a lot here: evolution, what we got, and what our plans for the future are. Each February, essentially, we complete another calendar year of incident and accident data with our 30-day reporting lag. Incidents that happen in December get reported to us in January. By the beginning of February, we say we've got a complete year of another complete year of incident and accident data. So our current plan is to update each of the 4 projects probably during the month of February, depending on how fast we can do it, so that we maintain visibility of the most recent 10 complete years of incident and accident data. And if you noticed, the DOT definition was labeled interim. That always makes me leery. So DOT may update that disadvantaged community layer. And if they do, the next time we roll in a new calendar year of data, we certainly plan to implement any changes to the disadvantaged community GIS layer that DOT might come up with. And we're ready for live demo. So there, you're going to throw a switch somewhere. Uh-oh.
There are a lot of codes. Contacting the mothership.
Like, are people going to be able to pull that data layer into their GIS system?
Are you asking about the transportation disadvantaged communities data layer? You can already. If you, in the slides, there's a link. Okay, so I was ready for this. Yeah, I noticed that. So I got a couple screenshots that I'll throw up. Oh, well, I can't throw up the screenshots either. Yeah, so the disadvantaged interim definition of disadvantaged communities is available on the DOT website. So you can get that now. I know that industry has already done it. They wanted to they wanted to see if they could replicate our analysis, and they certainly did. So that GIS layer is out there. Our incident and accident data is available, and it's got the lat longs in it, which is what we used. So I wish I could show the tools to you, but they haven't been released for the public. If they released for the public, it would have been real easy. Just go to a website. But we're here trying to make my DOT connected laptop show it to us, and we're not having much success. Do you want to let James?
Yeah.
Well, James is going to be in the same boat probably. Okay, so why don't we do James do his presentation, and hopefully his computer will cooperate, and I'll maybe do it from the back.
Yes. 2-minute break. Talk amongst yourselves. Yours is just one.
Yeah. Okay, perfect.
Even less.
Yeah. Great. Well, it's, great to be here. First conference for me. I started at the Pipeline Safety Trust almost a year ago. In a couple weeks, it'll be a solid year. And I put this page up specifically because, I guess you can't really read it, but the graph on the screen shows a date of 2015. And when I came into the trust, that was the state a lot of our data was in, a lot of our public facing kind of presentation data was in. It was a lot of stuff that was made, very well thought out and put together by Rebecca and Carl over the years. But for the most part, they didn't have the capacity to kind of constantly be working on it and constantly be updating it and keeping it as up to date as possible with all of PHMS's, releases. So I came in with a pretty big task and started working with some pretty big data. I don't know how many of you have opened PHMS's flagged files, but there's about 630 something columns and thousands of rows. So my first day was kind of like, okay, well, where do I start? And Carl and Blaine really each separately kind of took me through PHMS's data, took me through their sort of Oracle database and their different data pages. And I started to orient myself and kind of feel out, not just how can we update what we have, which is still, as you can see, in progress, but how can we start to improve on how we share data with the public? Because there's plenty of work going on within the industry for how data is collected, maintained, shared. But our focus really, or my focus, was coming in and saying, all right, well, people who live near pipelines, people who are interested in these issues, ought to have a better idea of what these issues really look like. So in that process, we started coming up with different public-facing projects that could kind of accomplish these goals. And one of those that some of you may have seen is our recurring state of safety, which we try to do monthly. Sometimes it turns into 6 weeks, but that's how time works. And this has been kind of an ongoing and evolving project. When we started, it started as an internal project, and I can't remember if it was Bill or Kenny or somebody at the trust that asked, hey, this is internal, but can we start doing this for every state, and can we put it out to the public instead of just looking at it ourselves? And of course, the answer was yes, and we started setting out to share data about each state, about their incident rates, about the operators in those states, and what causes incidents in those states. And recently, we started, taking the draft posts to state regulators and asking them their opinion, and that not only helped us improve sort of the accuracy or the validity of what we were sharing, but it also helped us improve sort of the approach that we were taking in the first place. And I pulled up Minnesota specifically because this was the first state that we kind of took that process on with, and it was hugely educational and hugely beneficial to start doing that. So if there are any regulators in the room who haven't seen your state yet, I guess get ready. Might not be this year, and it might not be next year because there's 50 states, but we'll see, and I look forward to hearing from you when that time comes. But aside from this, and aside from updating everything from our briefing papers to graphs that we share on social media, we've also started thinking about how to make things more engaging for users, and kind of bringing the data not just literally from 2012 to 2022, but kind of figuratively. How can we make something that's interactive, engaging, fun to look at, and fun to sort of play with, if you let me use that term. So the inspiration for what I'm going to kind of talk about today is something that Carl started several years ago that he had called the monthly perp walk. And this is the most recent monthly perp walk that was on our website. And if you zoom in on these dates, you'll see 2018, 2019. And this was just looking at the worst incident in each system in each month. And that was what the perp walk was. It was which operator, where, and how big was each incident. And it was an interesting project. I kind of gravitated towards it early on because this really distilled that pretty massive wall of data into like, okay, well, what's really bad, and what's kind of temporal and relevant. So we took what was a spreadsheet basically, and we wanted to turn it into something that's a little more interactive that I'm going to have to refresh, and something that would be updated with a lot more regularity, if it loads reasonably quickly. There we go. And there we go. Nice little welcome screen for you. And this will be on our website soon. It's kind of going through a soft launch phase, which I'm going to plug right now if you want to be a part of that and kind of get early access and give me feedback. I'm sure some of you will have feedback for me today, which is, also always appreciated. But this is the same thing as that spreadsheet, effectively. It's just presented in a different way, and with a few more features to sort of give people a different look at what those sort of worst of the month incidents look like. And we also kind of changed the name. We're calling it the monthly incident dashboard, but that's, a separate conversation. So as you can see, we have each of the three sort of major systems, and you're looking at September's worst incidents. And you might think, well, how are you determining the worst incidents? The default, what Carl had done several years ago, was using release size. But we wanted to kind of give people the option to kind of determine the worst incidents based on what they might value. If you want to choose the worst incidents by the cost of the damage, you can do that. If you want to choose the worst incidents based on, say, deaths and injuries, you can also do that. And you'll notice that, especially when you use deaths and injuries, sometimes you don't have those every system every month. So that's accounted for as much as possible. And if you only want to look at one of the systems, you can do that too. And kind of crucially, this kind of lower left portion of the dashboard carries over to all the other tabs that you have up here. So if you're only concerned about one type of determinant and you're only concerned about one system, you don't have to change that every time you change tabs. So I'm just going to kind of quickly go through these tabs so you folks can get at least a quick idea of what we're trying to do here. This next one is a table of operators that have appeared on the worst of the month list multiple times. And each operator, the parentheses, you see how many times they've appeared on the list. You see for which systems, and a total sum of deaths, injuries, evacuated members of the public. You see what percentage of those incidents caught on fire, exploded, and the total releases, and the total cost, and sort of all those pieces of data. And if you're really interested in one more than others, feel free to click on it and it'll drop down with all the incidents that made that worst of the month list, which I really want to be clear about. This is not every incident for each operator. It's just the ones that made the worst list. And you can kind of move ahead to the monthly map where you see all the incidents in the month. You see the size based on whatever your determinant is. And you can click on circles and it'll tell you, all about that incident. And if you get lost, because, sometimes people do, you can always just go back to the start. And the last sort of important tab is this incident plotting tab, which, we added a few more controls, including a light and dark switch, which was requested by somebody, which, by the way, yeah, again, like feedback, please give it to me because I am always happy to implement requests if they're useful. And you can, I didn't mean for that to be funny, but you can change the size of these dots by different determinants as well. And it kind of has a similar feature where if you scroll over them, it shows you a little more information about each incident. And this is kind of a dorky thing that I added, but you can log the y-axis if you like seeing kind of the difference in, that there's a lot of bunching around the x-axis. This is kind of more of a wonky thing that I added there that most people probably won't use. And finally, I said that's the last kind of important tab. This is just the table of all the worst of the month incidents. And I really want to be clear about that because it's been part of the feedback that we've gotten, is that everything that you're seeing that comes in like a table form, I'm just talking about the worst incidents every month. And this table is completely sortable and searchable. So if you want to find, I won't use Enbridge, but I'll use Enterprise, I guess. And you can find all the incidents that, made the worst of the month list from Enterprise, for example, and a little bit of data on each of those. So, there's a few things to kind of click through and chew on. And if anybody's interested in testing it, please reach out to me, stop me, send me an email, whatever it is. Reach me by one of the mice that are still scurrying around. If you haven't seen them, I've seen a couple since getting on the stage. They know where to reach me. But yeah, please let me know. I'm always interested in feedback from folks, especially folks who aren't as familiar with the data. That's been kind of the guiding the guiding question that I ask in a lot of meetings is, who is our audience, and how can we make data products that reach our audience in ways that are understandable, that are comprehensible, and that are valid and credible. So yeah, that's I think that's my time, because Kenny's about to raise the end of session. Hopefully Blaine is ready in the back, I think. Yes? Okay, great.
All right, so can you all hear me? I got another mic. Okay. Oh, and you can see me. So this is what we have set up as our landing page for the GIS tools for equity. You see we've got a little blurb here about the Equity and Transportation Task Force and the executive orders that preceded the creation of the task force. And as I mentioned, our plan is to have 4 projects. Right now, we've got 2 of them in a ready state, and I'm going to show them to you. And then down here is a link to the DOT Justice 40 initiative site, and that includes the Transportation Disadvantaged dashboard link to get to that GIS layer. So click on the gas distribution, and you come to the gas distribution tool. Clever, isn't it? Come on. So this is our gas distribution pipeline incidents by state and by transportation disadvantaged community status. We say a little bit more about what the community's data is. You can click here to see a quick definition, and then a little bit about our GD incident reports. And as you can see here, our national values for gas distribution incidents, we had 1,058 in the 10-year period, and 319 in disadvantaged communities, 799 in non-disadvantaged. And then, as I mentioned, you can click here and access the spreadsheet that gives you data about the incidents, data about the census tracts in the disadvantaged community layer. And here's the excavation damage front matter. Somebody talked earlier about getting geospatial data for leaks rather than for incidents. So here in the pipeline excavation damage write-up, we started out talking about something that we don't have GIS data for. Excavation damage is the leading cause of hazardous leaks on gas distribution facilities. And during just 2021, there were 76,000 hazardous leaks on gas distribution pipelines caused by excavation damage. That's a whole lot of GIS data that we don't have. You can see down here, 646 is the number of incidents across the 10-year period for all pipeline system types. And just in gas distribution, 76,000 hazardous leaks in a single calendar year. So if we want to take that plunge to GIS data for leaks, not just GIS data for incidents, it's a big plunge. Lots of leaks that we would need lat longs for. And then the rest of this front matter talks more about excavation damage and incidents. And again, links you back out to other places on our website where you can get more information about incidents, and click here to get to the spreadsheets. So that's the top of the tools. Each tool has 2 maps. So in the spirit of being in Louisiana, well, actually, let me cover the legend first. So the dots, the orange dots, are incidents that occurred in disadvantaged communities. The gray dots are in non-disadvantaged communities. The orangish hashing is disadvantaged community census tracts. And then that's not my music. The color shading is just an indication of the number of incidents in states. So let's look at Louisiana. You come over here to the select a state and say, okay, I want to see Louisiana. And that's what you get. Let me move the legend out of the way. And then you also get a pop-up for the state of Louisiana. Here's how many gas distribution incidents there were in a 10-year period, how many are in non-disadvantaged areas, voila. So there's your state layer. Now, if I zoom in, oh, I did it the right direction. I almost always do the wrong direction first. So if you zoom in and click, you get more layers. You get the state layer because that's what you're in. And then you see here you're one of 4. Then you can go over and you can see about the incident, the year, the actual report ID, and this gas distribution 2013-0051. We've got all the data on our website if you want to find it. In the spreadsheet that I talked about, we have the key fields. You can see the cause of the incident, its county, and its disadvantaged status. Then the third layer, I'm going to grab the map. So this particular incident was sort of almost at this zoom level on the boundary of 2 census tracts. So from this position, maybe it was in this census tract with its FIPS number, or maybe it was in this census tract. If I zoomed in even more, I could probably make the system decide which census tract it's in. So that's your top map. Essentially, you go to a state, and then you see all the incidents, and it's really just a visual tool. I'm looking at a state, and I want to see, what are the incidents that have occurred in disadvantaged areas, and what are those that have occurred in non-disadvantaged areas. The bottom map, so that was one map. Here's 2 map. It has additional ways to filter. You can select by an operator ID. So if I go, okay, I'm in Louisiana again. I got to wait till it builds. I'm in Louisiana again. I didn't wait long enough. I'm sorry. All right, are you done building? I'm in Louisiana. So now I can select an operator ID for Louisiana. The operator name will show up down here. We had a little bit of a problem. Some operators change their name. So 6240 might be in here with 2 different names. So we got a solution for that in out years. But for this first year, it's Washington Parish Gas Utility District number 2. And so that's their single incident. So it's pretty unexciting to do additional filtering. But for some of your larger operators that have more incidents than others, it could be 1 minute. Okay, like if you go to gas distribution or the excavation damage incidents, and here you can actually find operators in multiple states. If I select an operator, select an operator.
Hey, Blaine, should we take a question or two and you could let the audience know whether it's something that can be?
Yes, we can. So here's Colonial. There's Colonial Pipelines. And you don't get a real good zoom when you pick the operator. You got to sort of self zoom after that. So you can do by state and then by operator, or you can do operator, then state. It's really up to you how you want to try to use the second map on the page with the filters. And that's it.
Okay, why don't we take a couple of questions for Blaine, a couple of questions for James, and end with Graham.
This is Scott Courier with the visualization of it. What kind of trends are you seeing? What are your takeaways from what we're looking at here with respect to trends?
We're really not looking to trend data. What we wanted to do is provide a visual tool where stakeholders can see incidents and see, are they in disadvantaged communities or are they not? As I said, our plan is to update them annually to have the most recent 10 years of data. So we're not talking performance targets. We're not talking trend analysis. We're talking a tool to see how incident locations overlay with disadvantaged communities.
But the observers can do their own kind of trend analysis. Is that correct?
We're making the data available for stakeholders, yes, to do whatever they might want to do with it. And that not to say we won't in the future, but right now our goals are fairly straightforward. We want to give you visual tools to see the incidents in the context of disadvantaged communities.
Will you be letting the broader audience of users like the media know that this tool is out there?
We're working on, we being PHMSA is working on a rollout plan. Not finished, but underway. So that would involve, our social media and the usual things we do for a rollout plan.
Any other questions for Blaine?
Actually, I have a question for Graham.
Okay.
Yeah. First, thanks, Graham, for your presentation. Your company to define the severity thresholds for pipeline performance. Is that correct?
Yes. Yeah.
Level. And are you also able to quantitatively measure the effect of any mitigation in terms of reducing the risk to your defined acceptable level?
So yes, but when it comes down to like risk tolerance and stuff, I think there's more effective tools in our toolbox where we get into, and it's probably not can't do it justice to get into the right level of detail, but we'll use like reliability targets rather than getting into risk tolerance. You take the standpoint that, well, no incident's acceptable. Let's get our reliability to a point where, this is the incident becomes beyond plausible. Okay. And so, but in terms of, I would say more, frequent and retail presentations of performance, then that's where these tier 1s and tier 2s are there and useful for us. Because it's a very quick and simple snapshot at your performance. Number of tier 1s this year versus last year versus here's the trend over 5 years. Like it's very simple stuff. You can blend the tier 1 and tier 2 metrics into an overall frequency, with weighted numbers and look at the overall impact for a period of time. And it's crude and it's not necessarily entirely intended to be this, but if you look at incidents as risk realized, then that frequency times the number of severity 1, severity 2 type events really does give you a risk profile. Realized risk profile. And so on Z260, one of the regulators that was working on the standard has actually pursued that as a way for themselves to categorize all the regulated companies. Because again, it's a realized risk profile that you get by looking at those frequencies and of the tier 1 and tier 2 events. And I say it's really good for that fast look. So, yeah.
And just a quick comment for the audience, having spoken to Graham before today about his presentation, we were thinking about what kinds of data would be useful for prevention. And of course, that would be very interesting for everybody to think about. And one of the points that Graham made was the number of immediate repairs that are required, because that means there's something not quite right in what's going on in terms of prevention, that there needs an immediate response. So another question?
Yeah, I think I'm next. Carl from the Pipeline Safety Trust, and this is for anybody. I think first maybe off to Graham. It seems like we're getting more and more data and we're calling it different things. It used to be there was 2 or 3. There was incidents, serious incidents, significant incidents. Now with, 1186, there's going to be tier 1, tier 2, tier 3, tier 4, and now there's IPE. So there's like 8 or 9 different categories of incidents. So instead of making it easier for the public to understand, we're actually making it more complicated. And with the 1186, anything under 420 gallons won't be reported at all to the public. Anything under 300,000 cubic feet won't be reported. And if you compare that to PHMSA, you're going to look at very different graphs. So if what we started with is trying to make it easier and more concise to understand, it seems like we've gone the wrong direction. So tell me how that's not true.
Well, so I would say, if you are used to working just in the U.S., then yeah, you've got PHMSA and that's a tremendous data source, all at your fingertips and stuff. And you could rely on just that one national regulator. But then if you're dealing with stuff that doesn't get reported to PHMSA, you've got no basis for comparison. I'm Canadian. I work for a company that runs pipelines across the border. And, there's no consistency between, jurisdictions. And if I want to compare, and as I've been often asked to do is, well, how do we compare to some of our shippers in terms of performance? They got pipelines too. I can't answer that. And so it's about trying to get a lexicon for like the whole industry. It's the same, that tier 1, 2, 3, 4 is the same terminology that's used in the midstream and the refining sectors. It's the same terminology that's used in the upstream sectors. And so it is a change if you're used to just PHMSA. If you're already working across jurisdictions, as a lot of industrial players are, and there's a lot of pipeline analysts, financial analysts are, then it's finally that consistency that you're looking for that allows you to make those comparisons. And so unfortunately, it's something new to get used to. I would say I don't think it's a step back. In terms of the IPEs were very helpful. They were very influential, and there's a pretty darn good line of sight between what's in the Z260 API 1186 definitions in PHMSA IPE. Okay. In terms of the last question, though, about like the minimum reporting volumes and stuff. So the data, probably, let me back up a second. Probably one of the best uses for the standard is as filters for the public data repositories. We've taken the frameworks and we've run the PHMSA data through it and be able to spit out, like, okay, this company's got this pyramid, this company's got this pyramid, and what does it look like en masse? And so in terms of what companies report out, I'm gonna say, unfortunately, companies are gonna report what companies are gonna report. You can't force them to do something that they're not gonna do. But the reporting into PHMSA and the fact that you've still got this 5-gallon reporting criteria is still a value. And it's just a matter of when you're trying to sit down as an industry association and, do some benchmarking. Or if I'm going to report out on Enbridge's performance at the, in our corporate and social responsibility report, I'm going to use the tier 1 and tier 2 because alternative is I can use, this indices requirements or this analyst requirements or any number of different definitions, and it's going to be all over the place. Well, now I can say, listen, apologies if this bothers anyone, but I'm just going to adopt the standard. This is what it is. And by the way, this is the exact same information we give our board of directors. And they see everything, but they see it as tier 1s, 2s, and 3s, and it's instantly recognizable. It instantly has meaning for them. So, yeah.
Bruce.
Is this on? Yeah. One for James and then one for Blaine and James. James, on the, I couldn't see from back here, but on the monthly report that you had for one of the states, was that just significant incidents or is it all reportable incidents? So it's even a broader. database?
Which
Significant from, PHMSA standards.
So when we're looking at the worst of the month,
Yeah.
I mean, they're pretty much all significant.
Right.
But when you're looking at the map and the graph, that is just all incidents. But when you click or when you scroll to get the little info box, the tooltip, it does specify if it's significant or serious, along with some other information. Yeah.
Yeah, and I ask it just because when I saw the list, and this is 1 month, and I had this list of 20 for one state, I'm just going, what the heck? We got a long way to go. Anyway, the second question I have is to my impression, why we're doing gathering this data is to make an impression, to impress upon states what's happening in their state, so maybe they can act on it, to impress upon companies what their record is, though they probably should know it, to get them to act on it, to sort of find out for the public and for the media who the bad actors are, who the good actors are. So with regard to this database that you're setting up.
And quick answers would be appreciated because we're out of time. Thanks.
I guess I'll answer first, and then Blaine, if you want to also give your input. That's just seeing data, whether it's the way that PHMSA is used to presenting data. It's all an opportunity to kind of go back to the trust and kind of discuss, oh, well, why was this done for the past, however.
Let's give a round of applause to the presenters. Thanks, everybody, both on this panel and in the audience.
I'll come back.
It always
To be honest, I specified a couple of there just to see a lot of the pipeline information. So like a lot, when I sent it to folks who were playing stream already, I sent it to folks who were playing stream. And the feedback we get is a lot different because they just, there are a lot more questions about what things even mean. It's like, what is a significant incident? I'm like, oh, well, it's this thing. Like, you should probably read about this before you. But yeah, I mean, if you're interested, if you have an email, I can send you a link. Yes.
And so it'll be.
Yeah, of course. Yeah.
And then two, one more question.
Of course.
Start a conversation.
It's refreshing.
Yeah. I mean, I try to, when I can, I try to make the cause pretty apparent. And that's one of the things I actually got feedback from the state safety laws. The Minnesota one specifically was like, hey, you're looking at trying to say, giving some information on the operators in the state, maybe look at the cause because, and as soon as I got that feedback, I was like, of course, because some causes are, I would say like more operator controlled and some aren't. And excavation is all the way on that side, right?
And I assume this is the changer here?
Yeah.
Okay.
I've actually used myself.
Well, let me see. Yep, we're good. See which one he put up for me. I sent him a new one last night. See which one he got loaded. Well, we'll see. They're not paying any attention.
Two, check, 1, 2. All right, there we are. All right, so if we could all take our seats for our last session of the day, that would be great. So take your seats or stand quietly, whatever you prefer, as long as we're listening.
I'm standing between you and happy hour, so.
All right, see, we have a couple more folks coming in. Let's take our seats for this last session of the day, please.
I guess I need to stand over here on this side so I can see this thing.
All right. Seems like they're quieting down.
I can introduce myself. Well, you can say. I don't care. Should I just?
Yeah.
Go ahead. Okay, I'm going to go ahead and start it because I'm standing between you and the reception. Okay? Yes. So I'm going to go ahead and get started. My name is Mary Friend. I am the Director of Gas Pipeline Safety for the state of West Virginia. And just to give you a little perspective, I've been in the industry more years than I'd like to tell you. Work for an operator from West Virginia, standing up here and talking about gathering lines. Well, most of you probably don't know that West Texas, Pennsylvania, and Louisiana, and we were ahead of Oklahoma. So, and West Virginia has a long history and a lot of the early tools and the early methods of drilling developed in West Virginia, in Burning Springs, West Virginia. So that's the trivia for the day. So gas gathering lines are kind of my passion. I've been dealing with them for a lot of years. Just kind of here to give you a picture. This is the gathering function. It kind of gives you the whole perspective of the industry. It starts out in the fields, out in the gas gathering or the oil and gas fields. The gas is then transported to possibly a processing plant or through a compressor into a transmission line, ultimately going to the distribution system. Kind of a simplified cartoon. So the Natural Gas Act of 1968 provided PHMSA with jurisdiction over pipeline facilities from downhole to the burner tip. PHMSA chose not to regulate certain portions of them. They chose not to regulate downstream of the meter. That was covered adequately by the National Fuel Gas Code. They chose not to regulate downhole until 2016 when they added the storage fields and the storage wells to their jurisdiction. And they chose not to regulate production outside of the limits of any incorporated or unincorporated city, town, or village. So they really kind of didn't even regulate gathering lines for a number of years. So in 1992, Congress gave the authority to PHMSA to regulate gas gathering and to define gas gathering and to develop regulations for these regulated gas gathering lines. Now, PHMSA worked on this for a number of years. API RP 80 was published in 2000. This was the industry standard on where to determine the start of gathering, the end of production, and how to determine gathering lines. So in 2006, PHMSA published the gas gathering line definition. It became regulations. It relied on API RP 80 to define gas gathering and establish some regulatory requirements for the newly regulated gathering lines. One of the things was to establish the start and the endpoints of gas gathering as defined in 192.8, as defined in code and in the standard. It incorporated the API RP80 as a incorporated by reference addition or standard, and it established regulated gathering by class location. So class 2, 3, and 4 became regulated. Class 1, which was less than 10 buildings per mile, remained unregulated. So what PHMSA is doing is they're looking for those areas where there was a bigger impact on public safety to make those lines regulated. They also established the types of lines based on the materials and the pressures that those lines operated at. So this is a very, very simplified picture of production and gathering. You can see the productions listed in those light black lines. Those are the wells, the circles. Unfortunately, there is no symbol in Word or PowerPoint to designate a symbol, so I just had to use a circle. So the circles are wells, the black lines are gathering lines, or production lines, and the red is the gathering line. Now, one of the problems is terminology. What do you call it? What do you call production? What do you call flow lines? Industry calls it, folks, operators call it different things. So in the simple world, gathering starts where you have a commingling of two well lines. Up until that, it's production. Then it becomes gathering. You have some states who have defined gathering starts where it goes through the meter. The state of New York defines it as within 50 feet of the wellhead. Okay, most states rely on the API RP80. I even have a problem within the state of West Virginia that my oil and gas folks who monitor the wells call everything from the well to the meter gathering. And everything downstream of the meter is production, which is the exact opposite of what I call it. So there really is no standard for what's called gathering and production. Some unique characteristics of gathering lines is they have their highest pressure at the beginning of their life. They're attached to the wells. The wells, when they're first drilled, are at their highest pressure. And as the pressure declines from the well, the pressure in the pipelines declines. So as the pipes or the lines age, the pressure reduces, and it's not as big an issue as those transmission lines that carry the same pressure year-round or all the time. Some of the other issues with gathering lines is they were constructed, or most of them were constructed, without any regulatory oversight. There are still wells in West Virginia that are over 100 years old that are economically viable and are still producing. Okay, so that means that pipeline is 100 years old. I have seen pipelines built out of well casing. I have 5-inch lines. I have 1-inch lines. I have lines with dresser couplings, lines that are screwed together. They used whatever they could. Okay. I put this picture up here because they're built without regulatory oversight. That black line is actually a production line suspended in the air. Okay. Yeah, those pictures that show them in the air, a lot of them come from West Virginia. They also use materials not approved by regulations. They use composite materials. They use some of these older materials. So we have a problem with the material not being appropriate. They use practices not consistent with regulations. They need to fix something, they go down to the local hardware store and get it, which may or may not be suitable for the pressures that line operates at. It becomes an issue. Then we also have inspection and testing practices. The goal was get that line in as quick as we can and get the well producing. That's how I'm going to make my money. I don't want to spend my money building a pipeline. These were actually, a lot of them are built above ground. So in 2006, they defined 2 types of gathering lines. There was type A, which are metallic lines operating at a hoop stress of greater than or equal to 20% SMIs, or non-metallic lines, which are mostly plastic. It could be composite materials, operated an MAOP of greater than 125 pounds. These are the ones located in class 2, 3, or 4 locations, and these were required to have full transmission regulatory requirements. They had to follow the same rules that transmission lines did. Type B lines are metallic with an MAOP producing a hoop stress of less than 20% SMICE, or non-metallic lines operating below 125 pounds. Class 3 and 4 locations or class 2 locations by one of 3 methods that PHMSA allowed operators to use. And they had limited regulatory requirements. Now, this kind of makes sense because there's lower pressure lines. And remember, I said that as they age, the pressure goes down. And so the requirements weren't quite as stringent. But the problem was when the rule came out in 2006, conventional wells were the ones that were being drilled. There was no anticipation of the growth of the technology of horizontal wells. The shale plays such as Marcellus and Bakken and Barnett were just starting to appear. So the regulations were not written for these new high pressure, large diameter gathering lines. And the problem becomes, and that's actually a picture from West Virginia. You can see it's fairly rural. But the problem is that line goes up and over the hill, comes down and goes, I won't call it a hollow, goes across a creek bottom, okay? And that creek bottom has people living there. Then it goes back up over the next hill. Nobody's living up on the hill. You can't build the houses on the hill. Comes down the other side, goes across another creek bottom with more houses, okay? These new gathering lines are operating at pressures that exceed most of the transmission lines. Typically, these are built to about 1,440 pounds. Most transmission lines are operating at about 1,000. And so the issue becomes aren't those people living next to those gathering lines in those bottoms, shouldn't they have the same safety aspects as somebody living next to a transmission line that's lower pressure? And then the gathering lines, like I said, may not have been built to regulatory standards. So it becomes an issue. So some of our challenges include the industry initials, API RP80, which kind of tries to strip out a lot of the gathering. There's a term called incidental gathering, which was kind of an oversight by PHMSA. In developing the rule, this allows lines coming out of a processing plant and taking that production gas to a transmission line. They didn't pull those into the regulations. So they defined this as incidental gathering. Okay, I'm okay with some incidental gathering, but there are operators who are claiming hundreds of miles of incidental gathering to get out of the regulatory requirements. So incidental gathering is an issue. Back after the mega rule was issued, the notice of proposed rulemaking for the mega rule was issued, API RP 1182 was written. This was industry's attempt to get out of some of the regulatory requirements by writing their own standard. Okay. The problem with that is it was limited to pipelines that were greater than 12 inches. And one of the problems with gathering lines is composite materials. These are things made such as fiber spar or flex steel. They're non-traditional materials. They're not accepted materials in code. And operators were afraid that when and if they became regulated, that they would no longer be able to use those materials. So composite materials were also a big issue. And that was part of the reason the 12-inch was used as a cutoff, because you can use coiled non-composite or composite materials up to 8-inch. Most of the lines above 12-inch were not composite. So the gas gathering final rule was issued last year, just a little over a year ago. It subjects all gas gathering lines, including previously unregulated lines, to PHMSA annual and incident reporting requirements. And PHMSA estimates that this covers about in excess of 425,000 miles of pipeline nationally. I actually wonder if that number is not a little low. I figure probably in the state of West Virginia, I have between 70 and 125,000 miles of gathering lines. And that's just West Virginia. That's just one state. So I think that number is a little low. The other thing that they did in this gas gathering final rule is they limited this incidental gathering term to 10 miles. Took away the ability to use it. So any operator in the future can only limit their incidental gathering to 10 and not use it for a long distance. So on the previously unregulated gas gathering lines where the operating pressure exceeds 20% SMIs in class 1 areas are now subject to certain safety standards. And PHMSA estimates that 91,000 additional miles of pipeline will be subject to damage prevention and emergency planning requirements. Again, public safety. 20,000 miles of additional pipe will be subjected to public awareness, line markers, corrosion control requirements, and leak survey requirements. And leak survey requirements also require the repair of hazardous leaks. An additional 14,000 miles of additional pipe will be subject to MAOP requirements. It means they have to test them and establish the MAOP of the line. And then it goes on to say that all new and replaced pipeline 8 inches or greater will have to be constructed in accordance with current pipeline safety regulations. So instead of being rogue and trying to decide I can build it the way I want, it's now subject to the regulations. It added 2 new categories of pipe, type R and type C. The effective date of the rule was May 16th, 2022. And all lines, including these type R lines, are going to have incident reporting after this date. Their first annual reports will be due in March of 2023. The type C lines, and I'm going to talk about this, type C lines need to be identified by November 16th, 2022. So sometime in the last 2 weeks, they had to identify these lines. And they have to compliance with safety standards by May 16th, 2023, although there is a limited stay of enforcement compliance that PHMSA has issued for some of the gathering lines. So the 2 types of lines are type R. I personally, I have never heard anybody say type R for reporting. Okay, it's reporting only. 192.8 says that type R lines as all other onshore gathering lines, specifically in class 1 and 2 locations. Okay, it says class 1 less than 8 inches in diameter, no pressure limitation. Now I'm going to tell you, I have been working with this rule for over a year. Okay. And I'm looking over my notes this morning prior to this presentation going, that statement is wrong. Okay, because type C lines are defined as lines 8 inches or larger that are operating above 20% SMIs. So those lines that are larger than 8 inches but operating below 20% SMIs also become type R lines. But that's one of the problems with this rule, is this regulation, is every time I read it, I see another nuance, another question. Okay, so type R lines are these class 1 locations, anything that's not a type A, B, or C. Okay, and then class 2 locations outside of the definitions. Type R lines are subject to reporting requirements only. They are not regulated gathering lines under Part 192. Okay, so they only have to report their miles and incidents and provide an annual report. So this is exactly what type R lines do. They have to provide the immediate notice of certain incidents. I think, if I remember correctly, there have been about 6 incidents on unregulated lines, on the type R lines, since the rule went into effect. They have to do then a written incident report, they have to do an annual report, and they also have to obtain an op ID, an operator identification number, for reporting purposes. So the other type of line PHMSA defined was a type C line. It's an outside diameter greater than 8 inch, and any one of the following. So if it's metallic with MAOP is producing a hoop stress in excess of 20% SMIs, if the hoop stress is unknown, a metallic line with an MAOP greater than 125 pounds, non-metallic pipe with greater than 125 pounds MAOP. And the non-metallic pipe could be plastic pipe, it could be composite materials. Kind of a quick summary of what this requirement is. This is an additive requirement. So all lines over 8 inch are subject to reporting requirements. That means they have to do an annual report, they have to do incident reports. They're subject to damage prevention and emergency plans, and new or replaced pipe must meet the requirements, the design and construction requirements that exist in code. Diameters 8 to 12 inches with a PIR exception have to have what's in the first section, but they also have to have public awareness. They have to have line markers. They have to have corrosion control, and they need to have leakage surveys. And actually it should be fixed leaks as well. And then pipelines between 12 and 16 inches with a PIR exception, or all pipelines above 16 inches need to meet the plastic pipe requirements, and they must establish a maximum allowable operating pressure. I'm going to go through some of this stuff real quick. It needs to meet the reporting requirements of Part 191. It needs to have a damage prevention program, which means they need to participate in a one call. They need to make sure that their lines are protected and not hit. They have to develop emergency plans as outlined in 192.615. And to me, this is really important. How do they respond in an emergency? I've been listening all day to these emergencies and how emergency responders respond or don't respond what they understand about the lines. And this is where it becomes important. They need to understand these are gathering lines, and they need to have an emergency plan on what they're going to do if the line fails. Prior to now, they never had to have an emergency plan. They also have to keep records documenting the methodology that they use to determine their start and stop locations. And this is not just for type C lines, it's also for type A and B lines. They also have to meet all the design requirements. And this is not the one I corrected because I have an error. It should be the testing requirements of subpart J, not subpart K. So I will acknowledge I made a mistake there. And they have to meet those design and construction requirements and testing requirements for all new, replaced or relocated or otherwise changed pipelines. One note is existing composite materials are grandfathered. So pipelines that are built out of fiber spar or flex steel can continue to operate. And actually code allowed for special permits for operators to install them again in the future. Even though they're not authorized materials through code, operators can apply for a special permit to install those lines. All gathering lines greater than, that's the one I just had, excuse me. So if the pipeline is less than 16 inches in diameter, they also might apply for a PIR exception. So this allows operators to parse the line according to population adjacent to the pipeline. Remember I told the story about that line going up and over the hill and coming across the bottom and going back up over the hill? Well, this method allows them to parse it. So the only place they have to do some of those requirements is for where the population is adjacent to the pipeline. And that part of the line that goes up and over the hill doesn't need the same requirements because nobody lives along it. So the methods they can parse the line is method 1, where there is no building for human occupancy within the PIR of the pipeline. The second one is the segment is not located in a class location building or class location that contains a building intended for human occupancy or other impacted site. So kind of doing the numbers, 24-inch pipeline operating at 1,440 pounds is kind of the split over between whether I use method 1 or method 2. So this is a real quick kind of analogy. The diagram on the left kind of shows the PIR, and if I have an identified site and I'm moving my PIR, which is potential impact radius, down the pipeline, where I first hit that impacted site becomes regulated, and it stays regulated until the PIR no longer touches that identified site. This is just the same as used in integrity management. On the other side, I simply use a class location unit, 660 feet on either side of the pipeline. So if I have a house within 660 feet, it qualifies or does not qualify for the PIR exemption. Both of these methods use buildings suitable for human occupants. These either things such as houses, office buildings, stores, restaurants, factories, outside recreation areas. They also use the term other impacted sites. These are things such as small, well-defined areas occupied by 20 or more persons at least 5 days a week for 10 weeks out of the year. Again, the same information is used in class location. This is things such as ball fields, picnic areas, rest areas. And then they added this one, which is the definition for a moderate consequence area. It's any portion of a paved surface of a designated interstate, other freeway or expressway, or other principal arterial, and arterial is spelled wrong, with four or more lanes. The comment was made earlier about the event. Sissonville was an event in West Virginia that took out the interstate for about 12 hours because the event happened right next to the interstate. And this definition was added because of that particular event. So when we talk about pipelines now, we've talked about this PIR exemption, but pipelines, all pipelines with PIR exemption and pipelines greater than 16 inches must also have a public awareness plan according to 192.616. This is public awareness, not engagement. They have to install pipeline markers. Now, I am going to tell you one of the most frustrating things in my job is trying to figure out who owns a line, because gathering lines are not required to install pipeline markers. So I'll get somebody calling in saying, hey, I've got a leak. Can you get somebody to come fix it? I have no idea who owns the line. They also have to do corrosion control. They have to do a leakage survey, and then they have to fix hazardous leaks. Pipelines 12 to 16 inches with a PIR exception, or pipelines greater than 16 inches must also establish a maximum allowable operating pressure. Okay. So type C lines are not required to have an O&M manual. We've heard discussion today when we talked about the section 114 things, and these are the written procedures operators follow to perform maintenance activities on their pipelines. Type C lines are not required to have an O&M manual. So one guy can do it one way, the next guy can come along and do it a different way. Okay, no standardization. They're also not required to have an OQ plan. Okay, so a lot of times the issue becomes that particularly with gathering line operators, sometimes they're looking at a fairly transient workforce. They may not be qualified, but they never have been trained to do some of the maintenance activities. They are not required to have an integrity management plan. They're not required to have a control room management plan. And they are exempt from certain construction and design requirements, mostly in terms of records and the type of records they have to keep. Type C lines are subject to drug and alcohol. Okay, because they are a regulated line under 192. They are subject to the Part 199 and Part 40 drug and alcohol requirements. So the question becomes, where's gathering start? Okay, well, gathering actually does start at that valve on the side of the wellhead. That's where the pipeline starts, but that's not necessarily where gathering starts. And you can see these are almost two extremes. The one on the left is probably a low pressure production well at this point. The one at the right is a higher pressure line. And you can tell just by looking at them that they're different. So API RP80 is the standard for determining what is regulated and what is not. But one of the problems with API RP80 is it does not address how horizontal wells were drilled. What we have is well pads with multiple horizontal legs from a single pad. And so the production then is commingled in a header at the pad. And those lines coming out of those pads are often 8, 10, 12 inches in diameter. So at least in my opinion, that header is the start of gathering. I have not gone through that exercise with my oil and gas folks to see who makes that decision, but that's the interpretation. Other locations are subject to operator interpretation. We basically have to go with what the operator identifies. We don't have enough personnel to do the analyses to determine, yes, this is gathering, or no, it's not. We also have operators who are unfamiliar with API RP80. They don't even acknowledge they have gathering. Hey, what do you mean gathering? I have 3 well lines. Then how do we get the word out regarding new regulations? The state of West Virginia, I sent out 1,200 letters to oil and gas well operators in the state of West Virginia, providing them information on the new gathering line regulations, providing them with resources, providing them with a method to get feedback to us or ask us questions, and not a single response. So I'm actually wondering whether or not the word has gotten out that these lines are now regulated or they have to report it. The gathering line issues are unique to state programs. States are the ones who regulate this, not the federal government. They are intrastate pipelines. And one of the problems we have is name changes. I think Blaine talked about somebody with 2 different name changes, same op ID. How about I have assets that have changed names once a year for the last 8 years? Okay, and there's not a pipeline marker to be found, not an emergency number to be found. They barely report it to us. So the name changes and trying to track these operators down is just tremendous. We have a lot of forms that we need to be using. Because PHMSA doesn't regulate, well, they regulate, but they don't inspect gathering lines. It's left to the states to determine how they're going to inspect and the forms they use. And my favorite story is I developed a form for the Type B lines. My group and I developed this form. 2 pages, really simple. So now in trying to implement these new Type C gathering line rules, Tim said, well, send me your form. So I sent them my form. They took my 2-page form and turned it into 59 pages. Okay. While I appreciate that, there's a lot of things on there that don't need to be, because the Type C lines are not required to follow the full transmission requirements. So we're still struggling with the forms. And one of our biggest issues is going to be, we don't know how many new operators we're getting. If you were to ask me today how much mileage is going to be added in the state of West Virginia, my response is going to be between 500 and 5,000 miles. I just don't know. But my bigger problem is not the existing operators. My problem is the operators who have never been regulated. So right now, I think the state of West Virginia, I think I have 66 operators in the state of West Virginia. I may add 10 more operators. Well, that's 10 more rounds of inspections we've got to do. That means we've got to do drug and alcohol. It means we got to do standards. It means we got to look at their public awareness plan. And that's on top of what we already do. I have no clue how many more inspectors I'm going to need. And I think all of us with gathering lines are in that problem. I believe the state of Texas, who has the largest amount of gathering lines, has estimated they need 20 additional inspectors to cover these new gathering line requirements. Okay, so that's what I was. One additional comment on this is, when you get new inspectors, they cannot immediately start inspecting. You have to get them trained, and that's a 2 to 3 year process to get your inspectors trained. So the reality is, PHMSA didn't create 2 classifications. They created 4. Okay, so I've got these Type R lines. I've got these C lines between 8 and 12 inches. I've got these Type C lines between 12 and 16 inches, and then I have the pipelines greater than 16. They were categorized by size and pressure, but what's going to happen is operators are parsing their lines into multiple segments. So a single 60-mile pipeline segment may have 2 or 3 areas of type C, then they may have a PIR exemption, and then they may go to a type A. Okay, what do I do? How do you inspect it? How do you piecemeal it? There's a lot of confusion regarding requirements, and I even admitted to you I'm still confused. I still see things I have not seen before. And then the maintenance cost is abandoned. The concern really is not the lower pressure lines. The concern is these higher pressure, larger diameter lines. So some of the challenges we face with type R lines is the location of the pipelines. 100-year-old pipeline, do you know where it is? You can make a best guess. You probably don't know where it is. Okay. 100 years old, the age of the pipelines, the materials they use, their legacy construction issues. I threw this picture up, and I will please, this is not in the United States, this picture. Okay. But this is the kind of things you can find on some of these older areas. Maintenance issues and emergency response. Emergency response is huge. Type R lines don't need pipeline markers, so how do we get the stuff fixed? We also have exposed pipe on these type R lines. Right-of-way issues, damage prevention. In the state of West Virginia, pipelines less than 3 inches do not need to belong to one call. And that's a state regulations, that's not a federal. And then lastly, leaks. We can't force the operators on the type R lines to fix the leaks because there's no regulatory authority to do so. And one of the biggest frustrations is getting those phone calls in that say, I have a leak on my property. Can you get it fixed? And my response is, I will see what I can do. And if I can figure out the operator, can usually give them a call or send them a note and attempt to get it fixed, but it doesn't work all the time. And when we talk about emissions, it's some of these unregulated lines that are the biggest issue. So what we need are gathering lines that the regulations that make sense, that protect the public, that compliance then is easy to implement and understand. Like I say, I struggle with this. And then we need a balance between safety and other issues. So with that, I'll leave you my contact information and see if there are any questions. Oh, Christy, you can't ask one.
So I'm going to play, thank you, Mary, for your presentation. I'm going to play devil's advocate for a second. I guess I'm curious as to how PHMSA has issued these new regulations for gathering lines without the valuable input that NAPSR members or states would provide, or is some of the things that you're sharing now a result of learning more beyond those initial discussions with the regulations?
It's a combination, but the biggest issue, and I think Max talked about it a couple of times this morning, is the ex parte. And I think John talked about it too, that we're treated as a member of public. So once it goes into a rulemaking process, we are not allowed input into the regulations. And I think a lot of the problems could be solved that way. I do know that this rule was negotiated more than some other rules were. A lot of pushback by industry. So.
Mary, Glenn Archambault, Jackson County. So does any of this get buried by requirements of any kind? And does local government require any kind of a permit to excavate or grade or anything of that nature?
In terms of building lines?
Yes.
No.
No.
Because usually once the well is drilled, there's a lease between the landowner and the person drilling the well. It's liquid. The others are, and okay, end session. Thank you all.
Thank you, Mary. We are done from us. So we'll see you down there for some snacks and some drinks shortly.
People have asked about our annual beignet walk over to the Café du Monde. We are not a